Welcome, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers. And we're here today to have a fun time to discuss networking and cloud computing. These are going to be some critical cloud computing technical skills, network skills training, and these are really going to be essential cloud architect skills. And this is critical cloud architect training because if you don't know the fundamentals and you don't know how to design your IP addressing plan, everything comes crashing down. So this is good cloud architect training. We're gonna cover, I'm sure, some cloud architect career tips because people will ask. This is cloud career training because if you want cloud as a career, or you want to know AWS networking training, you need to know subnetting. You need to know about classful and classless addressing. What is classless interdomain routing, otherwise known as what is CIDR. You need to know subnetting, variable length subnet masks. We'll do some variable length subnet masks exercises. We'll do lots of subnetting, and we'll make sure that you guys have fun. So everybody get ready for some networking for cloud computing training. It's AWS networking training. We'll cover what is CIDR, subnetting, and variable length subnet manning. And this is going to be fun, 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 fun. It's a chance for me to take a step down from my CEO role, put my network engineering hat back on like I spent in my youth, and have party time, party time, party time. Got a lot of things to announce, but I want to tell you why I'm excited to teach this. I've been in networking now for 25 years. I'm one of the original Cisco certified internet experts. Back when it was a 2-day exam, before Cisco determined that it was too hard and people kept failing it, so they made the complicated exam a single-day exam, and they removed half of the complexity. But I'm from that legacy, that old group, that original group that really, really, really dug deep. And here's what I'm going to tell you. When I passed that exam, that's when the networking started. That's when it all began. That's when my learning began. The CCIE can and will always be my favorite introductory certification. And here's the reason why. After that, that was when I got to start to work on the projects that caused me to learn networking. And we love it. So we're going to make sure you all learn subnetting today because your IP addressing and your plan determines whether your systems work or whether your systems do not work. So, like I said, the CCIE is where I began learning networking, and we're going to teach you networking. I'm also going to tell you the following. If you've taken a CCNP A class or a CCNP class, or you took an introductory networking class like the AWS Advanced Networking, you found it hard. Here's the reason why. The instructor didn't know it well enough. I'm going to tell you right now, Albert Einstein was right. If when you take something and it's hard, it's because the instructor didn't know it well enough to communicate it simply. And I will make sure in simple, effective, plain language that we make sure you know subnetting. But in the next week, we have so many initiatives to help you build your career. I want to talk about them while we wait for YouTube to notify people to join us for this subnetting workshop, because this is networking for cloud computing. And this is critical networking and cloud computing training. And it's going to be fun, fun, fun. So here's the thing. Tomorrow, we're going to do a BGP workshop. I'm one of the original BGP people. I've been consulting on BGP. Just today, I had an article on Hacker Noon and securing BGP and protecting BGP hijacking. The world's been coming to me for years, and I want to share that experience with you tomorrow, completely free. And you know what else we're going to do tomorrow? I want you all getting cloud hired. I see questions in the chat box like, do I need a CCNA? Well, tomorrow you come to our completely free How to Get Your First Cloud Architect Job webinar. You'll come on this webinar. We'll tell you everything you need to do to get hired. We'll tell you how to leverage your life experience to show the hiring manager you've got work experience. We will, for example, we will tell you how to interview for a job. We will tell you what needs to be on your resume, etc., and we will make it real fun. So it's going to be really good, and we will have lots of time. So let's keep this in the back of your mind. You know what else we're going to do next week? We're going to take one of my students. He's one of my favorite students. He's like a little brother to me. His name is Delroy Batt. He came to me a year ago. He was with me for 3 weeks. We got him multiple security jobs. Now, a year later, 25 years old, I think he's 25. He may have turned 25. He might be 24. Last time I saw him, he was 24. He just got hired by CDW as a cloud security architect. He's really, really excited. A psychologist of mine, student of mine, got hired last week. We'll be announcing that one soon. Jermaine, who's one of my students, is an amazing guy who in a landscaping business, for example, got his first cloud architect job. And all of you can too by having the right skills, etc., etc., etc. So kind of keep that in the back of your mind. So Delroy will come in on next Tuesday. He'll be part of the Head in the Cloud show. But today we want to focus on, what we're talking about? Subnetting, networking, and it's going to be lots and lots of fun. So let's work through this. And we just sent a message to my team. So what are we going to talk about today? We're going to talk about what is subnetting. Before we do this, I forgot something. My team's messaging me. Next week, guess what we're going to do completely free? A free AWS Certified Solution Architect Associate Bootcamp. And I promise you, it's not going to be PowerPoint slides with audio. We would never do that. It's going to be a real class. We'll talk, discuss, and present for 20 minutes, and you'll ask questions for 10 minutes. Because at the end of the day, I want to know that you've got the knowledge. PowerPoint slides with audio is not training at all. Maybe in 1998 it might have been, but not now. I would never, ever give that to somebody. It doesn't count as training. Even our free training, we would never do that. So in our training, we're going to have our free AWS Bootcamp. I'm going to send you home with some labs to do. You'll sign up and you can do it. And that way we can focus on the knowledge. Knowledge is what helps you pass the interview, not the name of a service and how to configure that. I promise you're never going to go on a cloud architect interview and they're going to say, set up an S3 bucket for me. Never. But they are going to ask you to describe object storage. When do you use it? When do you not use it? How do you make it work? They do care about that. So before we begin, give me a hashtag and call it, let's say, hashtag AWS Networking Training. Give me a hashtag that says AWS Networking Training. We got lots of people here. I want to know you're awake, alert, and oriented. And let's get into the fun. But please give me a full hashtag AWS Networking Training. I see 168 of you. So I'm looking to see 168 of these to make sure that you're here. While you're at it, before we begin, you want to give a like? Great. If you know us, subscribe to the channel, hit the bell, so you get notified of the BGP workshop tomorrow. You get notified of the free AWS Advanced Networking tomorrow. There might be a free interview practice session coming real soon too. Chris from my team obviously knows the dates. I don't know any of the dates. I go where Chris tells me to go and when he tells me to go there. It's because he makes sure that all the things we do are out there helping the community. So I'm seeing all this AWS networking training. Sean, one of my great students, is now a working cloud architect. Wonderful and thrilled to see you over here. Fantastic. I'm seeing some amazing folks out there. Even Ivadokia, so good to see you. Hope to see you in class real soon. Great to see you, Ivadokia. So many wonderful people here. So what we're going to talk about today is what is subnetting. And then we're going to talk about what are classful addresses. Then we're going to go into what goes into subnetting. And we're going to get into the why. It's all about the why. Love it. I'm so happy to see you back. Then we're going to teach you how to supernet. And then we're going to do some practice. Yes, practice. Now, practice makes permanent, good or bad. When somebody says, I've got 30 years experience, that means nothing to me. They could be the worst person in the world doing bad things for 30 years, or they could be great at their job. So the point is as follows. We're going to teach you how to do it perfectly so you get some perfect practice. And that's when we make perfect practice makes things permanent. Then we'll do some subnetting and supernetting, which is the exact opposite, which is critical for route aggregation and traffic engineering. Critical for BGP. Can't do the job if you don't know how to do these things. Then we'll talk about subnet planning so you know the kind of subnets to use and where. And then we'll talk about designing. And if you guys want and we have time, maybe together we'll design a multi-cloud architecture and the IP addressing scheme for it, or if not today, we'll do it on the BGP day. And no, using a subnet calculator is not going to help you in real life because you need to see the subnets. You need to understand them. You need to pretty much be able to plan and see it in the map. Like if you were going to plan a road and a plan of routes through the city systems, you need to know what you need to know. And if you tried to cheat with a calculator and you can't see what the roads are going to look like, and your IP addressing scheme will show you what the roads are, then you can't design the roads. So it's not like we can use tools here. We have to know it. Imagine if a doctor, you went to see them in their office and they said, here, let me check my calculator so I know how to diagnose you. You'd walk out of the room. But if you walked into the doctor, they asked you some questions, they examined you, they made a diagnosis and gave you a plan and you got healthy, you're going to like it. So we're going to teach you how to be the doctor. Hey, by the way, and want to know my background? I used to practice internal medicine before I moved into tech 25 years ago. Internal medicine taught me how to be an architect. Here's the thing. A patient would come in, they'd say, my head hurts. I'd ask them about their headache, what makes it better or worse. I would examine them. I'd make a diagnosis and a treatment plan. Hey, wait, I'm a cloud architect. I meet with a client. Tell me about your business goals, your business pain points, your business challenge. Then I assess their current technology system. Then I make a diagnosis and I make a plan. Whoa, doctor interview patient, architect interview a patient. Doctor asks some questions, architect asks some questions. Doctor examine the patient, architect examine the patient. Doctor make a diagnosis, architect make a diagnosis. Doctor make a plan called the prescription, architect make a plan called an architecture. So that you would not want a doctor that needed a subnet calculator, and guess what? You can't have an architect that does too. So now you know why. So what is subnetting? Well, subnetting is like taking a pizza and chopping it up into little pieces so you can feed all your friends. So that's really all it is. It's taking one big IP network and chopping it down. Let's say you had a person with a contagious disease like COVID, and they had a pizza. Some of us are getting over COVID right now. And that one person ate from the pizza. Could you give that pizza to somebody else? No, they'd get sick, right? Well, here's the thing, and we'll talk about interfaces and systems. We have to chop the big networks down to use our IP addresses. We don't have sufficient IP addresses to do things. Heck, we ran out of IP addresses a long time ago. So we need to be very efficient with our IP addressing. I'm going to tell you a secret. Every interface needs to be on a separate network. So what does this mean? If a server has 8 Ethernet cards, they all need to be on a separate subnet, all 8 of them, unless you're doing a link aggregation bundle. So when I show you how critical this can be, without subnetting, you're going to see how we would totally destroy all the world's internet addresses in a matter of days. Now, IP addresses are old. We've got a newer version called IPv6, which you can talk about. But the point of subnetting is, how do you chop up your pizza to feed your friends? Now, let's put this into context. Let me give you a visual over here. In this visual, let's take a classful address. We're going to get into this nonsense classful addresses because when I started, when the dinosaurs roamed the earth, and when our routers had 16 megabytes of RAM in them, some people are still using classful addresses. But even then, people were getting off of classful addresses and into classless interdomain routing or subnetting. So imagine this. Imagine that you had to use, you've got a router with 4 ports, and each interface needed to be on a different subnet. Now, in this particular case, we use classful addresses, and somebody, I don't know why, but decided to assign a class A address, which we'll talk about in a minute, to each interface on the router. Now, what I want you to understand here is if we put a /8 or a class A on each interface, every single interface would basically waste 16 plus million addresses per interface. Now, I want you to think about this. 4 interfaces, 16 million addresses per interface, 64 million addresses used in a single router. Now, here's the reality. When we're dealing with a subnet, a subnet, we're dealing with something that's called the broadcast domain. So I want you to think about this. Have you ever been to a restaurant where it's loud inside because they're babble, 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 and you're trying to go on a date and you can't talk to your boyfriend, girlfriend, whatever, because there's too much noise in the room? Well, in networking, we've got systems. My Apple does all this broadcast for Apple systems identify each other. Windows systems do broadcast. Your applications do broadcast. We have a practical limitation as a rule that we can never put more than 500 systems in a single subnet. I'm going to say here again, we can never get beyond about 500 addresses in a single subnet because of the broadcast that'll fill it out. How many people can you put in a restaurant before the noise gets so loud you can't hear anybody? About 500. Same thing here. So if we can only put a maximum of 500 addresses in a single subnet, and at the same time, we put a /8, which gives us 16.7 million addresses per subnet, we burn 16 million addresses when we only need 500. So that's the point of subnetting. Now, let's subnet it down some more. Let's say I have a WAN link, which is like a wire. So here's a point-to-point WAN link. Here, this is the wire. No, it happens to me, my iPhone headphones, but this is a WAN link. It's a wire. Your direct connection. A VPLS tunnel, like a Martini tunnel, which gives you a layer 2 Ethernet over MPLS. Anything. It's a single wire. So if you've got two people talking to each other, one here and one here, you only need 2 addresses. Now, this is for a WAN link. We'll talk about the cloud providers and the weird ways they do their IP addresses, and it's no big deal. It's simple to learn. But that's the key. The key right here, right now, is as follows. In this environment, I put a /30 subnet mask. So I've used 4 addresses for this link, 4 addresses for this link, 4 addresses for this link, and 4 addresses for this link. I just used 16 addresses. Now, I only could use 8, but I had to waste 2, but that's okay. In the previous example, I wasted 64 million addresses. So 16 versus 64 million. Whoa. Think about that. 16 versus 64 million. That's what we're really talking about here. Does that make sense so far, everybody? In the chat box, tell me that you understand. I get the subnetting so far. Tell me, I want to know you know it, because I'm always concerned about your ability to learn. I want to know that you're getting it. So make sure you get it. We're doing this. Say, I understand subnetting in the chat box. I want to know you're getting it. And we're going to keep working and build on this. Good, Sig Wolf. Jim Weaver, you're getting it. That's what I want to know. Adrian got it. Sean, you did not get it. Okay, well, Sean, let's do it one more time before I get into the math of how we do this. Every subnet we use, every interface needs to be on a separate subnet. Now, I'll do the math with you guys, but if I were to use a /8, each interface would use 16 million addresses. If I use a /30, each interface uses 4. So, Sean, you got it? Okay. So which would you do? You burn 4. Sean, think about it this way. If you had a pizza the size of New York City and you gave it to one person, they'd look at you and say, what am I supposed to do with that? And if you said you can eat it even though you have the flu directly off the pizza, they'd contaminate the pizza. Nobody else could eat it. But, Sean, if you chop that pizza into multiple little pieces, you could feed a whole lot of families that were hungry. That's what subnetting is. That's exactly what it is. And I will never say, do not use the /22 or below, ever, economy, ever. I can't even use the /22 because it's too big. That's going to give me 1,000 addresses, and I can't put more than 500 in a single place. So that's why we're doing this. That's exactly the reason why. Chop it up into smaller pieces. You can feed a lot more people. That's all we're trying to do here. So let's come out of it for a minute, and I want to show you what the classful addresses are. They don't exist anymore, by the way, everybody. They don't exist. We've got these Class A addresses. They started from 1 to 126. They have an 8-bit subnet mask, which means 255.0.0.0. We had the Class B addresses, which were the 128 to 191, and they all had a /16 subnet mask, 255.255.0.0. And then we have the Class C addresses, which begin at a 192 and they end at a 223. Now, when we get out of this, realistically speaking, we're starting to get into two different kinds of addresses. And these addresses, there's these multicast addresses, which are 224.239 in the first octet. We'll talk about what that means in a minute. And with that, we're dealing with IP multicast addresses. And don't worry, in the cloud, you're not going to be doing too much of this. Now, you may be creating something called the GRE tunnel, generic routing encapsulation tunnel, and you might be pushing your multicast through a cloud provider. You may occasionally deal with a small amount of IGMP, which is a protocol to join a multicast group should your multicast be there. But all in all, the clouds don't support multicast. All in all, we don't support multicast. So because of that, we're there. Class E's are experimental IP addresses. They were the 240.255. Guess what? Guess what? Guess what? Nobody used them ever. So kind of keep that in the back of your mind. So when we're dealing with a subnetting, we're dealing with something that's called the 32-bit address. And IP address has 4 octets. 192, octet 1. 168, octet 2. .0, octet 3. .0, octet 4. And we'll show you where the math for this comes from. But I want you to understand with every address, we have a combination of network bits and host bits. Combination of network bits and host bits. And I'll show you what that means in a second. So in this particular environment, I want you to think about it. In a Class A network, 1.0.0.0/8, I have 8 networking bits and 24 host bits. Want to know how many IP addresses this subnet has? Here's the math, everybody. 2 to the 24th power minus 2. Easy to figure out. 2 to the exponent number of bits times minus 2. And I'll show you why we minus 2. You want to know how that is? Well, you could do 2, 4, 8, 16, 32, 64, and calculate it all the way up in your head. I've done it lots of times. Or what you could do is you can go to your calculator, a scientific calculator, and type 2 exponent 24. You got an answer? Subtract 2, and you know how to do it. Now in the Class B addresses, we've got a 16-bit network address, 172.16. And we got 16 host bits, .0.0, 172.16.0.0. That is a Class B address. Want to know how many host bits you're going to get here? Somewhere around 65,000. 2 to the 16th power minus 2. You got it. 2 to the 16th minus 2. We're going to get into some of the math that's going to make it a little more clear. But there's 32 bits in an address. And there's 4 octets. So 2 to the 16th minus 2. And I saw it 65534. Let's see who was the good math person. Economy, good job. Now the next case is a Class C address. A Class C address has 24 network bits and 8 host bits. How many hosts can we put in the subnet? Well, 2 to the 8th minus 2. Now this is classful addresses. And when we subnet it down, the math on this is going to make much, much, much more sense. But in the old days, when the dinosaurs roamed the earth, when people had CCIE numbers like me below 10,000, some of us actually got to work with classful addresses. But most of us did not. Most of us actually started working with subnetting because the point is we had to bear it down. So can you confirm practical use to never use subnets? So almighty, that was the problem that's going on is the way it was phrased by the person that wrote in the chat box got it backwards. We can never use a subnet bigger than a /23, not smaller than a /22. That's the problem. That's when I saw it, I didn't understand what it meant. Because we can never put more than 500 addresses in a system. So that's a /23, meaning we can't go bigger than a /23. So for Neil, if you have 32 bits, 8 bits plus 8 bits plus 8 bits plus 8 bits, how many bits is that? 32. Now, is this with IPv version 4? Is it binary, hexadecimal? It's binary. When it comes to binary, there's two options, 0 or 1. Now, Neil, if you're American, you see 0 is nothing that counts and 1 is the first whole number. But Neil, if you're European or English, when you go to the first floor to a hotel, it's 0. And the next floor is 1. So with binary, we get 0 or 1. So if you have 24 networking bits, the only number you have 8 host bits, what can it be? Each host bit can be on and off, and I'll get you to the math very soon. So as follows, 2 to the 8th is the maximum number of hosts you could put on that subnet. Now, if we had a /23 instead of a /24, which we'll get to later, we would have 9 host bits. How many hosts could we put on that subnet? 2 to the 9th. What if we had a /22, which we can never use? We would have 32 bits, right? 10 host bits, 22 networking bits with a /22. What would that be? 2 to the 10th minus 2. 1,024, I think, or 1,028 minus 2. So Neil, we're going to get to this math very quickly. And you are British. Good. So you understand 0 is the first floor and 1 is the second floor. So binary address is 22222. 0 or 1, on or off. And we're going to get to this soon, but Neil, let me just pop it on this slide to make it a little bit clear. 128. We're going to do this again. We'll do this in a minute, but I think this will help you.
And Mike, make sure to share your screen.
I'm going to once I write it down.
Gotcha.
And I'm going to try and show you something, but we're going to spend a lot more time on this. 4, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8. And Neil, we're taking this a little out of context just for you, which is because I want to make sure you get it. We'll try and spend 5 minutes on this, and if not, I promise you're going to get it when we get to it. So in this particular case, this is what we're dealing with, which is why everything is exponential. I don't know why my Slack thing. Because I have too many windows that open up on this system. So Neil, in this particular case, let's say for this last bit over here, I've got 8 host bits. And it's either 0 or 1, right? So the way we count is left to right in subnetting math. Those of you like me that learn to read right to left, that's another story based upon where you're from, but that's neither here nor there. So if I have 2, what I can do is in this particular case, look at this class C address where I've got n equals 24. That's network bits is 24, 8's are host. So what could occur as following is, the way this will occur is if I have, and we're doing this a little out of order, so it may be a little confusing. If I have 1 host bit turned on for the 128, and I've got 1 host bit turned on for the network, so these become network bits versus host bits, my subnet mask is going to be the following. 128 plus 64 equals 192. So in this case, I'd have a 255.255.255.255.192. And how many host bits would I have? I'd have this host bit, 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 and I'd have this host bit. So think about this. This is 0, 1, which is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So if I wanted to know how many hosts I'd have here, and we're going to get to the math appropriately, and it's going to make sense for you, I'd have 2 to the 5th, or 2 to the 6th, because I got 1, 2, 3, 4, 5, 6. 2 to the 6th, everybody. 2 exponent 6. 2. Let's do it together. 2, 4, 8, 16, 32, 64, minus 2. How many host bits? We're going to make it there. Also, we're going to leave this online for you so you can watch it again until you truly get it. I think it's going to be a little bit complicated until I actually get to the subnet math. But we'll get you there. I promise you, Neil. Just keep paying attention. So what is it really? When we take a network, we're just manipulating subnet bits and host bits. My address is 32 bits. 32 bits. I can split them any way I want. I can make them all network bits with a /32. 255, 255, 255, 255, which is called the host root. Or I can make 30 networking bits and 2 host bits, right? I could. That's a WAN link. What if I needed 8 host bits? It gives me 254 addresses. So what am I going to do? I'm going to look at the pizza that I have, and I'm going to see how many friends I have. And if I need to chop the pizza into 2 pieces, because I got 2 big buddies, I'm going to chop it into 2 pieces. If I've got 4 friends, I'm going to chop that pizza in enough pieces to give 4 of my friends. If I've got 8 friends, well, each person's getting a slice of pizza. If I've got 16 friends, they're all getting a 16th of a pizza. If I got 32 friends, they're getting a 32nd of a pizza. They're going to complain to me and say, Mike, I'm hungry. But that's what we're doing. We're borrowing bits. So let's look at subnetting, on a graphic basis, and we're going to work through a lot of these examples together to make sure you get it. So remember the class A, which was this, 8 bits of networking and 24 bits of host, and the class B, which was 16 bits of networking and 16 bits of host, and the class C, which was 24 bits of networking and 8 bits of host. What if I told you that the concept of classless interdomain routing or variable length subnet masks is as follows? I'm going to have Alonzo from my team use some new colors for this, because what's going on, apologies, is the green screen that I have behind me is interacting with the green and the color that we used when we designed this, and therefore it's causing some funny things to be here.
Hey, Mike, I have a quick question.
Yeah.
Can you click back on the box to the right? No. So the box that's got S equals blank?
Yes.
Can you click on it? All right. Up at the top, can you find the paint fill button? It looks like a paint can filling something.
Oh, okay. Yeah.
You might be able to change. Hey, let's change that to a non-green color. There we go.
Thanks, Chris.
Yeah, so you can do that in real time right now as we come across these.
Even better. Then I don't have to ask Alonzo from my team to help me do it. Here's the thing. About 20 years ago, I was CEO. I'd be at a CEO's office, and they're like, I know you're a networking guy, not a computer guy. This thing on my computer is not working. Could you how to help me? And I'd be like, sure. And the next thing I realized we had a good relationship. I had no idea until why nobody could learn until I became a CEO and got about 2,000 emails a day. And this kind of stuff happened. So now Chris has to teach me how to do these things. So thanks, Chris.
Yeah, and I will save everybody the trouble of me doing my Ric Flair woo from last night, because that's a very exciting problem we just solved.
So yeah, this is pretty great, and Chris is very helpful. I don't know what I would do without him. So think about it this way. Remember we had this 8 host bits, 24 subnet bits. But remember I told you that was going to burn 16 million addresses. But what if so now I'm going to determine the size of the pizza slices that I need. So if I need 500 hosts, what can I do? Very simply, I'm going to subnet this down. Right now I've got 16.7 million because I've got 8 networking bits. And the number of host bits is 2 to the 24th minus 2. But here, I can change this subnet bits right here. Instead of having 16 like I normally do, let's make it 12 bits of subnetting. So everybody help me out here. I've got 32, right? 32-bit address. 32 bits minus 12 plus 8 is how many? 20. So 32 minus 20 equals 12. We have 12 host bits because I subnetted it down. How many hosts can I put with 12 host bits? 0 and 1 is 2, so 2 to the 12th power. Somebody do 2 exponent 12 on your computer. Not me, because it's hard to do math and teach. 2 exponent 12 minus 2. And that's going to be the number of hosts. Somebody do 2 exponent 2. 2 exponent that. 4094 FE. Good job. Excellent, Raj. Good, good, good. Now let's play with, well, I'm going to put 15 bits here now. Just because it's fun. And we can make it anything we want. So now, 8 network bits and 8 subnet bits. 15 plus 8, 15 plus 8, 15 plus 8. That's 23, right? Okay. 32 minus 23 is what, everybody? I can play Jeopardy music. Do 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 bum 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 bum. 2 to the 9th. 512 minus 2 gives you 510. Good job, economy. Good job, Raj. Perfect number of subnet bits there, Chell, and I would expect nothing less from you, Chell, because you're a rock star. And Mr. Gee, fantastic, fantastic, fantastic. Let's say we played with it just a touch more, just like 1%. Whoops, didn't mean to do that. Let's say we played with it 1% more. Heck, let's add 16 bits here. Okay, everybody, 32 minus 16 plus 8. 16 plus 8, 16 plus 8. Remember Mr. Ed, the show, the horse that would go run, 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 and he would do 16 plus 8, and he would tell you it was 24. So we've got 8 host bits. How many addresses can we have in the subnet? 2 exponent 8. 256 minus 2. 254. And for some of the numbers that are a little bigger, you may be talking about a previous time, not really sure. So really, this is all it's about. Heck, let's say we've got 18 subnet bits here. Let's play some Jeopardy and have some fun. 18 plus 8 equals 26, right? 32 minus 26 equals what? 6. 2 exponent 6 minus 2. Tell me how many hosts we have left. Chow, good job. 2 exponent 6. Good, 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 good. Neil, if you haven't gotten it yet, you probably will. I will tell you this, in order to win, you got to fight until you get it. I didn't know that I was not born to CCIE. I was not born practicing internal medicine. There are times I struggled, and you know what I did? I fought and fought some more until I win. I never quit until the end. So it's up to you, Neil. But I suggest you stay and fight. Nothing good comes easy. If you're struggling with something, but you've got a goal, fight to win. Play to win. Continue here. Rewatch it and rewatch it and rewatch it, and you will get it. But if you've got a goal or a dream, never quit until you get to the goal. I'll give you a little example, Neil, and I'm going to get back to the concept. About 12 years ago, because I was doing some martial arts training. I was invited to be part of a martial arts delegation in Israel because of my 20 years of martial arts background. And while I was there, I was training with some of the best Krav Maga fighters in the world, and I loved it. While I was there, I shattered my foot in about 4 different places. I taped it up and continued to play every day, 16 hours a day of training. Now, unfortunately, what I didn't know was my body was beaten up so badly, Neil, that when I got home, I lost the use of my left hand and left foot. And I needed to go to physical therapy for 8 hours, 6 to 8 hours a day for 7 years straight just to be able to walk up and down the stairs of my house. And it hurt horribly. But what did I do? Fight, 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 fight. So what do I want you to do, Neil? Fight, 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 fight. That's how you get somewhere. And then rewatch and rewatch and rewatch. So I'm back online, which I think is going to make it a little easier. So let's do this. And okay, I got a question. Neil made something that I understand. Subnetting is as follows. We're taking the bits of this 32-bit related address. We've got an address, right? It's 32 bits. We're changing the bits from networking to host, and that's it. That's it. So if I've got 8 networking bits and 16 subnetting bits become networking bits. That's it. So they become networking bits. So if we've got 8 networking bits and 16 subnetting bits, we've got 8 plus 18, which is 26. 20, which gives us the host bits, which is 32 minus 26, which is 6. That's how we get there. Let's play it a different name. So let's say, for example, that we had as following. A class B address by nature, which is a /16, which means by default, an unsubnetted class B address. What do we have? 16 network bits, 16 host bits. Every interface on a router or a computer needs to be on a different subnet. Everyone. So now, I want you to think about this. 16 subnetting bits and 16 host bits. How many host bits do I have? 2 to the 16th minus 2. What is that number? 2 to the 16th power minus 2. 2 exponent 16. That's a class B. 2 exponent 16. I'm going to tell you right now, it's going to be 65,534. Good job, Eugene. Eugene's a rock solid cloud engineer. I know him. He's one of my students. Raj, you got it. Effie, you got it. Economy. Now instead,
I
if I
have
make
a
a
quick
class B,
question
which is
for you.
16 networking bits and 16 host bits, I realized that I can't put ever more than 500 addresses in a single subnet. So by doing so in this current situation, I've wasted 65,000 addresses. Okay, so far so good, right? So, and we'll take some questions right here, and then we'll actually get to the content again in a minute. So right now, I want you to think about it. 16 and 16. I only want 500 hosts and a subnet. So I'm going to move some of the host bits to the network. I'm going to call them subnetting bits. So I need 500 hosts. How many hosts does that mean? Well, 2 to whatever power gives you 512. Now I can tell you right now that it's /23, etc., etc., etc. So here's the thing. If I need 500 addresses, I need a /23. So basically what I'm doing is instead of the 16 networking bits, we're going to add the 16 plus 7 networking bits. 16 plus 7 networking bits equals 16 plus 7, somebody do the math? 23, right? Which means 9 host bits. Okay, so here's the thing. 2 exponent 9. And if you don't have a calculator like that with you, do the following. 2, 4, 8, 16, 32, 64, 128, 256, 512. 9, right? Then at my head. 9 minus 2, that gives us 512. Minus 2 equals 510. I got to the same math doing it in my head. Really doesn't matter how you do it. Now, I had a really good question.
Hey, Mike,
I use the subnetting calculator for the following reason. That's going to do all the math for you and hide it. You will never know any of it in your head. I want you to understand the mechanics of why. I want you to understand what's going on here under the hood, because I need you to know that. That's really the critical thing. What is going on? How is it working? And why do you use this? Because you're going to have to do this. And we're going to do a lot of these things today. We'll give you lots of examples to work through it, because I know It wasn't obvious to me the first time, the second time, or even the third time. But it will be obvious to you today. It's all about borrowing bits from one location to the other. So maybe this visual will make it a little easier. My buddy Alonzo drew it for me. I thought it was great. Here's what we're dealing with. On the one side of the equation, how many subnets do I need? We're going to work through that in a minute because I want you to know, you're going to need to know how many subnets you need. And I'll give you some practice problems right in a minute versus how many hosts do I need. That will determine whether we move the bits to the networking side, and subnetting is also considered networking, or to the host side. So hopefully that makes sense to you, and we'll get there. So let's do this. Let me take 5 minutes of questions, and then I want to get back to the math and really get us, and I'm going to show you what we need. And I'm going to give you some examples of how many subnets do we need. But Chris, are there any questions that I need to address?
I think you've addressed them as they came in. Let me scroll through real fast. But just to clarify, I can use a normal calculator to figure out 2 to the 6/8 power, right?
Absolutely.
Just don't use one of these subnetting calculators online.
Oh, no, because
okay.
Here's the thing.
Because I can't figure out 2 to the 6/8 power.
Yeah, really, we're never going to be dealing with subnets that give us /16s. We're going to be using them for route aggregation. We're never going to be dealing with that kind of mess anyway. Here's a secret, everybody. Except for when we do route aggregation, which we're going to talk about, we're going to use /30s for WAN and /24s for LAN. And we'll talk about the broad guess and the 0 and Y because all that stuff really matters. We're going to get there, don't you guys worry. And it's going to be fun, fun, fun. But until we get there, I wanted to make it clear. Remember, every interface needs to be on a different subnet. So what are you really going to be dealing with? 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, and you will never get bigger than 2 to the 9th, ever. And 2 to the 9th, 2, 4, 8, 16, 32, 64, 128, 256, 510. That's the biggest subnet you will ever deal with in your head. And guess what? I just did it all in my head, on my fingers and toes. So really all we're talking about is as follows. And hold on, I'm trying to watch. I've got three screens to watching. So let me watch, on StreamYard. And Chris, you can
watch StreamYard, please. Watch.
Are these always reserved for these purposes? Well, there's certain addresses that are going to be reserved, and we will go through those addresses that are going to be reserved very shortly. So what's going on is going to be as follows. We're going to be dealing with the 0, which is automatically going to be reserved, and I'll show you that soon. And we're going to be dealing with the what's going on, which is always going to be reserved. We're going to be dealing with the broadcast address, which is going to be all ones, and I'm going to show you that as well. So, and I don't know what's going on my screen. I've got one screen where it looks like I just saw about 180 comments come in the last 30 seconds. Don't know if that's actually going on. What is a host, Sean? Excellent. A router is a host. A server is a host. Anything that needs an IP address is a host. This cell phone right here is a host. Your refrigerator that sends you a text message that's plugged into your Wi-Fi, that's a host. The cable box in your house is a host. Anything that's plugged into the network. Any others for me, Chris?
I'm having to scroll through because you asked for lots of answers to math questions. So I got lots of lots of messages to scroll through. And you saw 180 messages coming in at once because you opened your YouTube thing or refreshed your YouTube thing.
Oh, okay.
Yeah. So because you're watching YouTube and StreamYard all at the same time.
I knew there was something complicated that I didn't completely understand. Okay, so if there's no more, we're going to start playing with it. I think there's a couple coming in. Ashwini, why the 2 concept? 0 plus 1. If 0 is a number, 1's a number. That's 2. That's all it takes. That's what we're dealing with, 2s. 0 is the first floor of the hotel. 1's the second floor. Sean's got what looks like a question over there. If a host is a server, why does a server need a subnet on it? It doesn't. Here's the thing, Sean. So let's say you and I want to communicate. I know you speak perfectly great British English, right? If you were speaking patois to me and I was speaking English to you, we've got a conflict, right? If you speak patois and I speak patois, we speak together. If you speak in English and I speak in English, we get together. Every time you get off of a subnet, you can't connect to anything without a router. So the point is, every system needs to be placed in a subnet. If you're in a different subnet than me, we can't talk to each other. So the server doesn't need to be in a subnet. The router needs to have the subnet, and the server needs an IP address inside of that subnet. So all this occurs at the routing or networking layer. So let's think of it this way. You're in my house, and today I'm speaking not Greek, we're speaking English, right? It's going to be lots of fun. Sean, I know where you're from. You're living in Germany. You're from Trinidad. You're all kinds of awesome. You're a great student and a great architect. So you come to my house, and I give you a place to plug in. If you plug into a subnet that's not on my network, you won't be able to talk to me or any of the systems on my network. You won't even be able to talk to the router. Now, in my house, I've got multiple subnets. I've got a subnet for my OpenStack cloud. I've got a subnet for my students in the demilitarized zone where the VPN in. I've got a subnet where I've got my critical security stuff, for example. And I got another subnet where guests plug in. When the guests plug into the subnet, I have an access control list between where the guests are and where I'm at. And that means when my buddy visits me and he gets to my house, he can't hack my systems from his subnet. So all systems need to be placed in a subnet. Now, Sean, on every server that you see, it has an IP address, right? It has a subnet mask. It is a DNS server, which maps a name to an IP address, right? But what else does it have? It has a default gateway. The default gateway is a router in your subnet. And what happens is when the host needs to go somewhere and it doesn't have a route on its routing table, it sends it to the default gateway. And the default gateway sends it off of that subnet by what's in its routing table. So everything, Sean, needs to be placed in a subnet. And servers in the same VLAN are in the same subnet who can communicate to each other. Servers who are in different VLANs need to be on different subnets, and they need to be, only way they can communicate to each other is with a router. Why would I create 4 VLANs on a switch? Because users in finance can't talk to users in HR, can't talk to the accounting people, and can't talk to the development people intentionally. So they can't talk to each other. And then I put an IP address on each VLAN and I route between them. Why do I do this? I can place an access control list on that router that says Sean can talk to Alonzo, but not Chow. And by doing that, I can further enhance the security of my systems. You get it? Perfect, 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 Sean. Are NAT and NAT gateway interchangeable terms? Not even close, Pawan. Gateway means router. NAT is network address translation. I want to speak to Pawan. Do you speak Hindi, Punjabi? Do you speak something else? So let's say I'm going to speak to you in Punjabi, and I speak English. NAT translates it back and forth. So what is network address translation? I am company A. My addresses are 10 on the 10/8 address space. Company A buys company B, whose addresses are also on the 10/8 address space. I can't talk to you and you can't talk to me if we have overlapping IP addresses. So one of the use cases now is to translate our private addresses to private addresses. Another use case in that might be you've got an IP address at the edge of your load balancer, public address, and all your servers are in a private subnet. That's effectively NAT that's going on. Now, I can do static NAT or dynamic NAT, for example. Static NAT is 192.168.1.1 always equals 3.4.5.6. Always, always, always. Might do that for a web server. I might, by comparison, need to take 50 IP addresses like in my house and translate them into a single address. That's called port address translation, or NAT overload. Now, what is AWS called a NAT gateway? They used to do it the simple way. They had a server that did NAT, and then a gateway called a router, and that was a NAT gateway. What AWS decided to do with the NAT gateway was quite frankly, had NAT and a router on the same device, and that's it. That's all a NAT gateway is. But NAT and NAT gateway are not interchangeable at all. What is network bits? Got 32 bits in an address. We can divide that address any way we want. More network bits, more host bits. 32 bits. 8 bits plus 8 bits plus 8 bits plus 8 bits. So there is that. Any others, Chris?
I think we can move forward.
Okay. So we're going to do a little bit of math. I'm going to try and show it to you. Lonzo made me a beautiful chart over here. Wrong button that I pushed here. Bear with me. So in this chart, let's talk about bits and exponents. If I have 1 bit of networking, I've got 2 hosts. But it's a worthless subnet for me. Here's the reason. The first address and the last address of a subnet are not usable under any circumstances. So one host bit gives me nothing. 2 host bits, 2 to the second power equals 2 times 2, 4. Get rid of the network address, which we'll talk about later. The broadcast address, guess what? I'm down to 2. 3 network bits. 2 times 2 is 4 times 2 is 8. Got rid of the broadcast address, get rid of the network address, and I've got 6, right? 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, 16. Get rid of the 0, get rid of the broadcast. Now I'm down to 14. 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Get rid of the 0, get rid of the broadcast, and I'm going to show you where this comes from. We're down with 30. Okay, now, you guys tell me. I've got 6 host bits. 2 to the 6 minus 2. Or, do it on your fingers and toes. I don't care. 2, 4, 8, 16, 32, 64 minus 2. 62. 7 bits, everybody. 7 host bits. How many addresses for 7 host bits? 2 to the 7th minus 2. Do the math. Or do it my way in your fingers and toes. I don't care. 2, 4, 8, 16, 32, 64, 128 minus 2. Raj, good job. LM, good job. Dustin, fantastic. Rupender Singh, excellent job there. Ruth, Chris, Mr. Gee, I'm loving it, loving it, loving it. Because we're going to get to some real fun examples of math and fun. Okay, 8 bits, everybody. 8 host bits. Somebody do it. 2, 4, 8, 16, etc., etc., etc. Somebody tell me how many we got. 8 host bits. Do the math for me, everybody. Do the math. Do the math. Mark Simpson, yes, 254. Kemi Thompson in the UK, fantastic. Vladimir, yes. Almighty, fantastic. Charles, yes. Sean, yes. Ruth, Sig over there in Germany. I'm loving this. Tracy, Pawan, Mr. Gee, exactly. Now, next, we're going to actually get to the biggest subnet we're ever going to deal with. Ever. The /23. That's the biggest subnet we get. So we have 32 minus 9, which gives us 23. Now I'm going to make you do the math both ways, just for fun. Tell me how many addresses I have with the /23. That is 9 bits of subnet math. So 2, 4, 8, 16, 32. 9 times. Economy, good job, 510, 510, beautiful, beautiful, beautiful. So go 510. Antonio, you're just off by a number. 2, Raj, 510, excellent, excellent. Okay, so let's think about this. I've got 32 addresses. 32 addresses, 32-bit address. I've used 9 bits. 4. 9 bits, which gives me 510 hosts per subnet. Now, how many subnets could I create with that? With 23 bits? Two to the 23rd, right? Et cetera, et cetera. So keep that in the back of your mind. We'll play with it. But you're always going to be going in one direction. Bigger networks, and the bigger networks are going to have a lower number. So when someone said smaller than a /22, smaller than a /22 is a /8. Lots of hosts of 16 million. Bigger than a /22, a /22 is already 1,000 addresses. It's just a matter of going in the right direction. That's all it is. So let me break it down a little more, because now we're going to get into the subnetting. If we have a /16, you guys just did the math. In my /16, you have 2 to the 16th addresses, minus 2, which was 65, I can't remember, but over 65,000 addresses. Now, how many addresses fit in the subnet? Maximum, about 500. Maximum. Because you got ARP broadcast and Bonjour broadcasts and server message block broadcast, NetBilly, NetBIOS, or whatever that Windows stuff is that is broadcasting out there. All your devices are broadcasting, broadcasting, broadcasting. If I could only use, so Marley did great math. I know Marley, so her math's going to be perfect. So Marla says we've got 65,534. Now, Marley, we can use 500 of them. So 65,500 minus 500 means we wasted 65,000 addresses. I don't know about you. I don't like wasting things. And since we're already out of IP addressing schemes, can we afford to waste IP addresses? Absolutely not. There's no way we could do it. It would cost us so much. So we have to understand what we're doing here. We have to utilize these addresses correctly and appropriately, and that's what's going on. So going back to our graphic here. Because we can't use all of these, when we add subnet bits, they actually become part of the network. So in this particular case, they become part of the network. So let's think about, what do we mean by part of the network? These 8 become part of this. They move left. So these 8 bits, these subnet bits become network bits. So now what we have here is we add N plus S equals networking bit. Here we got. So in this particular case, I got 16 networking bits and 8 host bits. Now, if I decide I need more networking bits and I make this 10, I got to subtract 2 over here because I've only got 32 bits that I've got. And that's going to change. So now, in order to do this, I have to take these 2 bits, convert them over to networking bits, and these zeros equal my host bits. That's all we're doing. So what you can see what we're doing is when we take our networking bits and our subnetting bits, they all become networking bits. And what we're left with is host bits. That's it. There's nothing more to this math. Networking bits become host bits. So go back here. Now let's put 12 bits in subnetting. How many bits do we have now that are part of the network? 16 plus 12, that equals 28, right? 32 bits, how many host bits do I have now? I have 4. That's all it is. Now let's say I want 11 subnetting bits. Now, if I've got 11 subnetting bits, they become networking bits. So what we do is we take 11 plus 16. That's that 27, right? 32 minus 27, what's that? 5. So now we've got 5 host bits. And here's what that's going to look like. And we're going to add another 1 to the zeros here. So really, it's the same. So let's add a slide and play with it a little bit. Let's bring this back to the appropriate number of bits that we had over here. Let's bring this to the number that it was. Bring this back to what it looked like. Let's play. Let's see what I got next for you. So let's map it out what these things look like. Now we're going to deal with binary, CIDR, and decimal. We can use any of the math things you want. They're all the same. When we're dealing with anything on IP addressing or networking, we're dealing with bits. And we have to, at some point, map it out to what it looks like. So, for example, right over here, these are the subnet sizes we're going to be working with. I've got a /24. A /24 means 255.255.255.0. Now, where did we get the /24? How many bits to an IP address? Somebody pop it in the chat box. Somebody, please, pop it in the chat box. How many bits to a total IP address? How many bits to a total IP address? Total, unsubnetting. In all 4 octets. Yeah, exactly, 32. Exactly. Mr. Gee, and the God, Dustin, exactly. 32. So we have a choice. We can shift them to the network side. We can shift them to the server side. I don't care. Somebody asked me, what's the right subnet? And I say, how many hosts do you need in that subnet? Huh? I need 32. Okay, here's your right subnet size. What? Subnet gives me 32 hosts. Actually, let's talk about it. Somebody tell me what subnet's going to give me 32 hosts. How many host bits do I need? Let's start with host bits. How many host bits do I need for 32 hosts? So 32 hosts in binary. 2 to the whatever minus 2. Which thing gives you 30 hosts? Raj, the /24 gives you 254. Although it will work. It's just too big of a subnet. Even though it's what you probably should use. Almighty. 32. Okay, see, Al, you said 3. 2 to the third is 8 minus 2. That's not going to work. Margin says 6. 2 to the 6th. 2, 4, 8, 16, 32, 64 minus 2. Almighty's will work, but he's got twice as many as he needs to. So 5 subnet bits. 2, 4, 8, 16, 32, minus 2. Ding, 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 ding. I need 5 subnet bits. So if I have 5 subnetting bits, and I've got a total of 32 bits, I'm sorry, if I have 5 host bits, maybe I'm confusing you. If I've got 5 host bits for the subnet, which to get to 32 addresses, how many bits do I have left for the network? Unfortunately, Vidalka, that's not right either. How many bits do I have for the network if I have a /27 eChris Nike? Exactly. So /27, how many bits of networking? FE27 eChris Nike, you have exactly 27 bits of networking bits. Exactly. Want to figure it out? 5 host bits, right? 32 total bits. 32 minus 5 equals 27. And Pawan, exactly. 5 networking bits will give you 30. Now, Pawan, what if I told you I needed 34 addresses? all you guys, I need 34 addresses now. What changes? For my 34 addresses, will they fit in the same subnet as before? Economy, good. I'm going to need 6 bits. I'm going to have to go with the /26 because I need 34. So 2 to the 6th, everybody. 2, 4, 8, 16, 32, 64. Minus 2, which covers the network and the broadcast. Gives me 62, right? Will 62 hold 34? Yes, it will. Exactly. So now let's play with this. Now we're going to play with a little bit of slides. I want it to make sense to you. This is a subnet. I'm going to calculate it together with you. And actually, while we're here, let me bring back my little Mike's funny math thing to remember. Because this always helped me when I started learning subnetting. 128, 64, 32, 16, 8, 4, 2, what do I have here? 6, 7, and then 1. Now, I just want you guys to understand the additive math. If I have, because we're going to do this, in this particular case, I'm going to have a 1 under the 128, a 1 under the 64, and a 0, a 0, a 0, a 0, a 0, and a 0. In this particular subnet, what's the math going to look like in decimal terms? What we're going to do is as follows. We're going to take the 128 and add it to the 64. That's going to give us a 192. And all these are zeros. What if I added another network MIT and a host here? What's that going to give us? 192 plus 32. Is that 224, everybody? Yes, it is. Now, I add another 1 over here. Convert this one to a 0. 128 plus 64 plus 32 plus 16. I'm thinking in my head that's 240. Now we're going to flip it the other way. So I say you can't use a subnet calculator. You got to see it in your head. Now I'm going to add that 1 here. Now what do I have? 128 plus 64 plus 32 plus 16 plus 8. What do we've got? 248. Hey, by the way, how many hosts do we have here? We've got 3 host bits, 5 networking bits. So how many hosts do we have available with this dot 248? Well, here's what we got. 2 to the 3rd minus 2. 8 minus 2. Want to know a secret? Another back-out way to do this? The subnet mask in this thing is 128 plus 64 plus 32 plus 16 plus 8. Is there any other cool little way to back out of this? Yes, there is. There sure is. If we do the math and we add the 128 plus the 64 plus the 32 plus the 16 plus the 8, gives us 248. Now, everybody, what's 2 to the 10th? I'm sorry, 2 to the 8th? It's 256. If we take 256 minus 248, what does that give us? 256 minus 248. 8, right? Minus 2. And we're there. So why is it 256 and not 255? Because we start counting at 0 and not 1, Richard. Now let's add another host bit. Another networking bit here. Now we have what's called a /30. 128 plus 64 plus 32 plus 16 plus 8 plus 4 Does that give us 252? It does. 252. So how many total addresses? 2 to the second power minus the broadcast address and the network address. 2 addresses. Now we turn this into a 1. And we use this subnet now. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2. What's that add up, Matt? To 254. Now what kind of addresses can we use here? 2 minus 2. 0. Can't use it. We get a total of 2 addresses minus the 0 minus the broadcast, and it's a dead subnet. And that's why we use a /30 for WAN link. Now, the next subnet we actually can use, but it's only for a loopback address and for nothing else. It's just called the /32. Now, this is really important. Everyone, you do the math. I want you to all see this and get it. What is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1? Do the math, do the math, do the math. You can use your fingers and toes. You can use a regular calculator for this. You can do an Excel spreadsheet. I don't care. Somebody add all these two. Sean Polaris, yes. PDA, Raj, you got it, 255. So when all 8 bits are turned on, it's 255. So now you guys are doing some awesome math. I'm so happy. I'm truly, truly happy. I'm very happy about all the math that you guys are doing. It is fantastic. Great job. You're all getting it. Nayan, I'm thrilled. Gladys, I'm thrilled. Ibadoikia, thank you so much. So this is what's looking good. So now I've got 24 bits of subnet mask looking like. Now here's what an IP addressing is going to look like. We're going to have this. Let's hold on. Let me figure out how to do this. I may need some PowerPoint lessons if it comes down to it. Octet 1, Octet 2, Octet 3. And I really hate being behind slides here, and I almost never do it. I hate it so badly. But some of this stuff is kind of complicated. So if this is what octet, so now I've got a /24. So that's what octet. So if I have a /24, I've got this in octet 1. I've got this in octet 2. I've got this in octet 3. And what do I have in octet 0? And octet 4. Hold on. Here's what I'm going to have in this particular situation. 0, 0, 0, 0, 0, 0, 0, and 0. That's what we're dealing with. That's a /24. What if I needed a /25? I turn this 1 on. Somebody tell me in decimal notation, what is the subnet mask? 255 plus 255 dot 255 dot what? What's in there? /25. First octet is going to be 255. The next octet is going to be 255. The octet after that is going to be 255. What's the next one going to be? Margin or Mr. Gee 128. Carl margin 128. Mr. Gee 128. Almighty. Yes, 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 yes. Okay, folks. I now have a /26. 255, 255, 255. /20, that was 25. We need a /26. Now what have I got? What's it going to be? 255, 255, 255 plus what is that last octet? Give you a hint. Exactly. Carlos, exactly. Marjan, Richard, exactly. It's going to be 192. Let's subnet it down some more. Now I need a /27. How many people are fitting in this thing? It's going to be 255.255.255 plus 128 plus 64 plus 32. Carlos, you got it. I can't pronounce that name. It's a nice African name, but I don't know how to pronounce it, and I'm so sorry. Ruth's got it. Raj, all kinds. So I'm loving this. I'd love to learn how to pronounce your name, sir, at some point. I'd love to meet you at some point as well. You guys are getting it. Now I got a /28. Smallest subnet you can use in AWS. What's that subnet going to look like, everybody? 255.255.255 plus 128, 64, 32 plus 16. You do the math. I already know it in my head. Chris, good job. Nargajana, good job. Tantum, good job. Master Guy, Martian, Carlos, yes. Now, you guys are doing fantastic. Guess what? Instead of a /28, I want a /29. What's it going to look like? You guys tell me. 255.255.255 plus 128 plus 64 plus 32 plus 16 plus 8. Yes, good job. Are coming into the .248s? No. Good. Add another bit. /30, everybody. 255.255.255. Russ, you're too smart. You already got there. Yeah, you got it. Achim, you got it. Carlos, you've got it. So great. Oops, didn't mean to do that. I don't know how I did that. But now you guys got it. That's the key. All this is, we got 32 bits. Move them this way, they become part of the network. Move them this way, you got more servers. Move them this way, you got bigger slices of pizza. Move them this way, you got smaller slices of pizza. So going back to this notation, because this is going to be important. This is binary. Ones, zeros. This is decimal notation. This is what you put in your computer. This is what we network engineers and architects think of in terms of slashes. This is what you see in the routing table, the slash, the CIDR notation. Doesn't matter. Water, agua, vasa, nero. Does it matter? Just call it something different. It really doesn't matter. Now, I'll mind it, the smallest subnet you can use in AWS is a /28. We're going to get to that soon. But you guys are going to do some projects first. So far, I think we've got everybody that understands except for one person. And that one person, I promise you, keep going back and back and back and fight to win. Get it, get it, get it. I got to tell you one thing. I hate math. Hate it. In my MBA program, there was some kind of advanced math course. I took it 3 times. I'm not proud to say it. I took it 3 times. But you know what? I finally got it. Now, it was the only course I've ever taken 3 times in my life, but I got it. So play to win and never quit until you get to your goals. Doesn't matter which language you use. We're going to get it. You're all going to get it. So now I'm going to give you a more complicated project. We're going to get a little deeper. The reason you can't use 2 addresses is as follows. I'm going to create a subnet, a /30. Okay, it's going to be a /30. And the /30 means 255.255.255.252. How many addresses is that maximum? 256 minus 252, the subnet mask, and you get 4. Or 2 to the 2 minus 4. So what's going to happen is the subnets are going to have a beginning and an end. And I'll draw it out with you. So what's going to happen is, let's just whiteboard it out. I want to make sure you guys get it. Let's say we want to create a WAN link. So we're going to do this. We're going to take this 192. We've been given a 192.168.0.0, let's say 1.0/24. This is our primary link. That's what we got. Here's our link. Now, I've got a WAN link, and here's what the link looks like. Router 1. Didn't need to do that. Router 2. New York and London. 2 connections, no big deal, right? How many addresses do I need on this link? 1 over here and 1 over here. That's it. Now, what subnet size will give me 2 addresses, A/30? So let's subnet this down together as a group. We have the 190, what's the first subnet going to be? It's going to be 192.168.1.0. That's going to be the first subnet. Now, inside of this subnet, this is the network address. Now, if you go to your router, you go to a Cisco router, and you can show IP route, that's what you're going to see. You're going to see this /24. That's going to be the route on the router until we submit it down. And for this WAN link, if I decide to use this subnet /30, 4 total hosts, right? From what we talked about before, only 4 of them. I'm not sure what's going on over here. Oh, I see what's going on over here. So we've got a total of 4 total hosts. This subnet's going to begin as follows. That's the network address, which we can't put on a host, but the router sees it. We have a 192.168.1.1, which is a usable address /30. Our next usable address is going to be 192.168.1.2/30. And there will also be this 192.168.1.3. Can't put this in a host. Here we got 2 people. We got Abigail Marks. We got Eva Doikya. They're both in the same subnet. If I want to send a ping to both of them, I send a ping to 192.168.1.3 because it's a broadcast for that subnet. I send that to the both, and they both say, "Hi, Mike, how are you today?" And I say, "Good," because it works that way. Now, that's why I can't put it on a host. It's a broadcast. So that's going to be the beginning first subnet that begins here. The next subnet begins at 192.168.1.4. Now, this .4/30 is the equivalent of this. It's going to be the thing that when I do show IP route, I'm going to see in my routing table, but that's not a usable address. And now Chris needs a link to Alonzo. And Chris's link is going to be a 192.168.1. Chris's house is .5/30. Alonzo's house is 192.168.1.6/30. And if I want to reach both Alonzo and Chris at the same time, I ping 192.168.1.7. Now, I have a cat named Cindy, who's the most beautiful little girl you've ever seen in your life. And Abigail has a cat named Noni, who's about as cute as my cat Cindy, maybe the same thing. She's the cutest thing, and they're good friends. The 2 of them love each other so much that Cindy wants to start sending her pictures that she takes on her cell phone directly over to her best friend Noni. So they need a WAN link between them. So now what goes on is Cindy gets a WAN link, and it's on the subnet 192.168.1.8/30. Noni, the cat, gets a WAN link 192.168.1.9/30. Now, on the other side of the link is my cat Cindy. She's got a WAN link with a 192.168.1.10/30. And now I want to send a broadcast to both cats and say, "Kitty cats, here's your tuna." And I want them to both see it at the same time. I send it to 192.168.1.11. Now, as it turns out, Chris has this beautiful orange Maine Coon. And Cindy wants to talk to Sonny, Chris's wonderful Maine Coon. So the next thing that I say is I need to build a WAN link between Cindy and Sunny. And here's the thing. Cindy likes to take cat photos like this and upside down and in the closet where she's in, jumping upside down, chasing bugs and birds. My cat likes to send photos. She's a selfie taker. And she wants to send photos of Sunny, who's a big and fluffy Maine Coon, because they're friends. They get placed another WAN link on another subnet, 192.168.1.12. Network address /30, 192.168.1.13. That's Cindy's subnet on her WAN link. Then we get to then on Sunny the cat's house, which is Chris's house. But of course, the cats are in charge of everything. Any of you that have cats know this. They own the house. You just live there. So then we've got a 1.14. That's Sunny the cat's tablet computer, which she takes selfies with. And now I want to do things to do this one. And we do 192.168.1.15/30. And that's it. That's how it's going to work. And dogs have masters and cats have servants. Exactly. We take care of our cute little babies. So as you can see, every subnet has a beginning, and we can't use this because that's the route. It's going to be on our routing table. We can't use this because this is how I reach out. Now, let's say, for example, I wanted to create a subnet where I'm going to put all the cats together. Could I put Cindy's computer and is there a specific reason you could use a 1 in the third octet and not 0? Economy, I don't understand what you mean here. Are you meaning why can't I use the 0? Because these zeros over here are considered the network address, and this is the broadcast address. No, right now, I want to put all the cats together in the same VLAN in the same switch. Cindy the cat's here. Cindy the cat's over here in my house. Sunny the cat's over here. Noni the cat's over here. And the last time I checked, another one of my students, I think it's Dustin, the guy that has the fruit and vegetable symbol, he's got a beautiful cat. So all 4 cats want to be in the same subnet. Can I use the /30 now? No. Why? It won't hold 4 cats in the same subnet. All their tablet computers won't work. So now I need a subnet that's big enough for 4 cats. So let's think about that. I can't use a /30. Let's think about what is a /29. 2 to the third power. 2 times 2 is 4 times 2 is 8. Minus 2 is 6. So now I've got 3 cats that I want to put in a subnet. So I need 3 host bits. Does that make it a /29, everybody? Joe G, good job. So now, in the subnet, let me set it up real quick. I'll set it up while we're setting it up. Chris, can you send me a text message of Sunny the cat?
Wait, say that again?
Can you send me a text or Slack message of Sunny?
Oh, I got lots of them. Do we want a mischievous Sunny, or we want a cute Sunny, or
a cute Sunny?
Okay, all right.
And I'm going to do the same thing. Bear with me a minute to set it up. I want to set up a good subnetting example. You can see my beautiful dot. Okay, actually, you know what? Perfect. I've got a photo of everybody other than Sunny, and I need a Sunny because she's a cute one. So let's set this up. We're going to have a router over here. Router, because this is going to be real networking. I want it to be set up. We've got a router, and then we're going to have a switch. I'm going to draw it real quick, and then I'll come off mute. I just want you guys to see it and have some fun. While you're waiting for me to draw this, can you guys give me a hashtag networking for cloud networking and cloud computing? Hashtag networking and cloud computing.
Okay, you should have a picture of Sunny now. I text it, and since you're on a fancy Apple, it should be on your computer.
Well,
Did you get it?
oh my God, is she cute?
I know. It
Okay.
was difficult. I had to stop looking because there's so many pictures.
You know, it's really funny. I've got 3 photos of me in my entire life, and I've got like 1,000 of my cat.
Exactly.
Not on me, but 1,000 of my cat.
Oh,
Okay,
yeah.
so on the left-hand side of this picture,
We
I'm
can't.
gonna share it with you in a second.
Okay. All right.
I have to make this look good, and we know my graphical skills. So let's do this. We've got this beautiful Noni the cat over here, and yes, I like anything with fur or feathers, but there's something special about some of these little girls and boys that we're dealing with over here. Oh my God, is she cute? So let's put this in over here, and then hold on. Now, if I wanted this to look really good, I would ask Alonzo, but we're doing it on the fly. Alonzo has much better graphic skills than me. So over here, we've got this little girl.
That doesn't mean we might not ask Alonso to do it anyway.
I might actually ask, yeah, exactly. So over here, we need one more little girl over here. We're going to put my little beautiful baby girl who likes to stand by my feet and get under my feet. So that's my little girl. So, okay, in this situation, we've got these 3 children. I'm going to share it, and then I need you guys to develop an IP addressing plan for them. So in this particular environment, we've got a very common scenario. We've got a router, we've got a switch, and then these little special people with our need, they each have their own tablet computer and their own iPhones. Now, this special little girl is Abigail Marx's cat. She's amazing. Her cat Noni is a beautiful little girl. Now, we also have Chris's cat Sunny, who's cute. And over here to the right, we have my beautiful baby daughter Cindy, who literally sleeps with me on my chest, in between my arm and my ribs all night, and she's the sweetest little girl in the world. Now, they all decided to start taking photos and sending photos back and forth to each other's computer. And they're all plugged into the same switch and the same VLAN. I need a minimum of 3 usable IP addresses. And I want you to think about all of this. Sunny, is Sunny a girl too? Chris?
Oh yes. Most definitely.
Okay, so in this particular situation, we're kind of challenged. We've got 3 little girls. So with these 3 little girls, how many addresses do we need to be able to give each one of them their own tablet computer so they can all text message all day long each other? We need 3 of them, right? 3 of them. So, and we're going to change this in a minute. We need 3 addresses. So what's the smallest subnet that I can use that will give me 3 addresses, everybody? Oh my God, I'm already seeing it. A /29 would be perfect. Would be perfect. Now, let's, Dustin, so let's say out of nowhere, let's say we find another cat out there. I don't know whose cat I can use. I don't have any other cat photos right now. But in this particular case,
I got a cat photo I can put.
Yeah, Slack it over to me.
Yeah, that's Slack or message.
Slack will be easier.
Okay. Now, if you prefer, we can make this a bad guy because this is
Yep,
a bad cat.
It can be that.
This is a bad.
We'll
cat.
use this cat as we'll use the cat as a hacker later too, but right
Okay.
now.
All right, give me just 1 second.
I'm going to show you what I'm going to give you some guidance to subnet planning.
You'll have to crop and zoom into it because it's kind of big. But Slack, you said?
Yes, it's going to be very Slack because now we're going to need to plan our subnets differently. Right now we need a /29, and Cindy, Sunny, and Noni, they're having a great time. We love them all.
You should have a picture of Moon.
Okay, in this particular, excellent. Let me download this photo.
You might have to
in
look
this
for
case,
it.
we have a boy.
Yes.
Okay, where did this thing go? Did it go to my desktop? Okay, let's find this again. Oh, I see where it went. Okay, I know what to do here. Now we've got a boy introduced to the subnet. Let's put a photo of this very handsome gentleman over here. Now we have a boy in the same subnet. Right now, we need 4 IP addresses. But we got a problem. Cindy thinks this is the most handsome cat she's ever seen in her life and is interested in him. They want to date. Sunny thinks this boy is very cute as well. And Noni loves the cat. So all 3 of them are interested in this guy. Now, in this particular case, we got one boy and a bunch of lady cats that love him. Do we think we might need bigger than a /29 in the future? If Noni starts to date Joey the cat, Cindy starts to date Joey the cat, and Sunny starts to date Joey the cat. Okay, now, Carlos, yes, moving up to a /28 minimum. Now, at this point, and I don't know why, all the cats love Joey the cat. And cats get pregnant for about 4 months or less until they have their babies. Do you think a /28 is going to be good now, McB, or one of my team? Probably not. Maybe I should use a /24 when she'll give me 254 hosts. So I'm going to give you some guidance to remember forever. /30 for WAN links. /24 for LAN links. If you do that, you're going to be pretty much good. If you think you need 10 servers, I promise you you're going to need 50. If you think you need 50, I promise you you're going to need 100. If you think you need 100, I promise you you're going to need 200. So all as a rule, we network architects say /30s for WAN, /24s for LAN. Except on AWS and the other clouds. And here's the reason why. In normal worlds, going back to what I showed you, the 0 is reserved for the network. The all 1s is reserved for the broadcast. Now, when you deal with AWS networking, and this is why it's AWS Networking Training today, here's what happens. The 0 is reserved. AWS then reserved the .1, the .2, and the .3, which is 4 addresses, and you still lose the broadcast. So, and then, yes, /32 is McB for the loopbacks, which I'll describe in a second. So what we're dealing with here is, generally speaking, /24 for your LANs. Now, if you got a /28 in normal networking words off the cloud, 2 to the 4th power, 2 times 2 is 4 times 2 is 16. I'm sorry, 2 times 2 is 4 times 2 is 8 times 2 is 16. Right? All good, right? Minus 2, 14 addresses. Now on AWS, 2 to the 4th power, 2, 4, 8, 16. But they burn 5 IP addresses. So what does that mean? 16 minus 5 gives you 11. So while you could use the /30 on a WAN link, you couldn't basically create a subnet for 2 hosts or 3 or like 4 hosts like this. And here's the reason why. They burn 5 of them. So the smallest subnet you could use is a /28. /30 for WAN links, /24 for LAN links, and that's it. That's all you need to know. Now you need to know how to plan it. So let's do some work together. Now, we're going to do the exact opposite. The exact opposite. So let's say now, and I will tell you what we're going to do now. I chop a pizza into 16 pieces. And I decide to give 4 people 4 pieces each. Now, if I chop a pizza that's got a, what do you call it? Let's say, for example, that I've got a pizza, 1 pizza, and I chop it into 16 pizzas. If I cut that pizza in quarters, everybody gets a quarter of the pizza. If I gave Jim Weaver 4 pizzas, and Ruth 4 pieces, and E. Chris 4 pieces, and McB 4 pieces, I gave out 16 pieces. Did I give Ruth a quarter of the pizza, E. Chris Nike a quarter of the pizza, McB a quarter of the pizza, and Jim Weaver a quarter of the pizza? Because each one got 4/16. They all got a quarter of the pizza. Now I can give them 4/16, or I can give them 1/4. Is it any different? What's 2/8, everybody? 1/4. What's 4/16, everybody? 1/4. What is 8/32, everybody? 1/4. What is 16 64? 1/4. Now, can we do this with anything? I got small pieces, I put them together and make a big piece. So I can take big pieces and chop them down. That's called subnetting. Supernetting is the exact opposite. I can take small things and make big things. Now, I want you to think about this. I work with an enterprise, and the enterprise has 30,000 subnets in their network. 30,000, that's nothing. And now we connect to AWS, and they say, you can only give us 100. 100. Wait, 30,000, I can only give them 100. Do you think this is going to present a problem for somebody? Here's a rule. If somebody doesn't know your network, your route, and you don't have their route, you can't reach them. So now you've got 30,000 routes in your data center and network. And AWS says, here, we'll take 100. 100. Now, not because AWS isn't careful. It's not because they're dumb. It's not because they're incapable. They have millions of customers to connect them, and they can't take millions of routes from everybody. So they give you 100. So if you consider each route to be a pizza, and right now, let's pretend you have a normal enterprise. You got 1,000 pizzas, 1,000 of them. And each one of these pizzas, beautiful pizzas, some have pepperoni, some have onions and mushrooms and peppers, some have spinach on it, all kinds of pizzas, some have feta cheese for the Greek people like me. You got all these great pizzas, right? And 1,000 pizzas are chopped up into quarters. It's 4,000 routes. And now you want to bring your pizzas from your data center to AWS, and they say, we're only going to take 100 of them. What if you could take it and you could take 4 or 5 pizzas and make them bigger pizzas and only send them the bigger pizzas? That's what we're going to do next. So I want you to think about it. And I want to make this real clear, because this piece that we're going to talk about next, this is the piece which causes most networks and clouds to break. You can't give them more than 100 routes. So how do you deal with it? When I connect to 8 internet service providers on my system, I've got 800,000 routes from 8 internet service providers. 800,000 times 8 via BGP. That's what I'm going to learn. I got AWS, and they say, we can take 100. So let's think about this. We can do what's called route summarization, and we must do it. Now, why can't AWS take a gazillion routes from you? Every route you give them takes CPU and DRAM memory. It takes memory. And every time a route goes up and down, it takes a recalculation in BGP, which causes the routers to calculate. Now, if any of you work with servers where the CPU went to 100%, they don't work, right? If your routers go to 100%, and the routers are exchanging BGP and OSPF messages and RSVP signaling and label searching for the MPLS backbone, and the CPU hits 100%, the hello messages, which are like keep alives or health checks between the routers, fail. And the router goes down, which causes all the routers to recalculate the routes. And the router goes back up, and it recalculates. And the CPUs get too busy. They basically recalculate. Somebody drops the connection, they recalculate. And what you'll find is too many routes will make the network go down. And this is where everybody messes this up. So I'm going to show you what good architecture is in terms of networking. Let's say I've got my data center, because this is normal. data center over here on premises. I don't care what you call it. No fill. Let me try to make this. Let me get my text the right color. Text. Okay, so I've got a data center over here. My data center has, well, let's just do this. This is the way a CCIE would do this. Now, over here, I've got AWS. I'm going to show you what other people do instead. What most people do that don't have a networking background. And I'm going to show you why the problem occurs. I've got Azure over here. Pretty normal environment. I don't know anybody that uses a single cloud. They'd be crazy too. Single cloud is a single point of failure. So crazy to do it. You got a WAN link to AWS, and you've got another WAN link to Azure. Yeah, didn't mean to do that. Not even sure how that happened. Now, think about this for a second. 10.0.0.0/24 what I did over here. One subnet, 10.1.0.0/24 is another 10.2 0.0 10.2.0.0 slash, actually these should be 16. I'll make them /24 just for the fun of it. Doesn't matter. And 10.3.0.0/24. Actually, I can't summarize them. I better make them 16s. 16. 16. Actually, I don't want to do that. So actually, let's make it a little easier. 1, 2, because I'm going to make you guys crazy with that. 3, 4. Bear with me while we draw this out. I like to kind of do these real-time kind of things and really give you an example. For AWS to know how to reach us, they don't need all of these routes. If I actually were to tell AWS, I could overly summarize it if I wanted to. If I told AWS to go to 10.0.0.0/8, go to the data center, and if I told Azure the same thing, and I could summarize this much more intelligently than this, I'm not going to be wasting any IP addresses. But AWS will know, hey, for anything in the 10 address space, send it to the data center. And Azure will know this as well. So what you'll see a guy like me or most CCIEs do, they'll put like a 172.1.16.0.0 for one cloud. And they'll use a CIDR range on the Azure cloud. Let's say 172.1.17.0.0/16 is their CIDR range. Here's the reason why. Our data center over here only needs to know how to reach the 172.16.1.0. And we only need to know how to reach the 172.17.1.0. So what's going on here? I'm going to be taking all of my subnets and sending one to AWS. So let's think about this. I want you to think about it this way. So I'm going to give you router instructions, and we're going to go back here. Here's what this means. What if I told you that you're going to visit St. Petersburg, Florida, because you want to go see Sonny the Cat and Chris? Now, here's the thing. I'm sitting here in Palm Beach, Florida. Do I need to know every street right now to get to Chris's house? I don't. What if I did this? What if I said, here's how to get to St. Petersburg, Florida. And when I got to St. Petersburg, Florida, I went to this gas station and they told me how to get there. I'd still get there, right? It would work. So if I told you, you need to go to Athens, Greece to go see my family in Peramos or Megiddo or wherever, I've got family in both places. And you said, how do I get there? And I said, here, go to Atlanta, fly to London, fly to Athens. And when you get there, call my Aunt Eleni and she'll come pick you up. Did you really need every street in Greece? Not one bit, not even for a second. You just need to know how to get there. So what we're dealing with is supernetting, which we're going to do correctly, is in our data centers, we're going to have these specific subnets because we need the specificity of our subnets. What we're going to do is tell everybody else, come to me when you get there. So for example, my wife's home, and I say, Alonzo, come to my house. If you come to my house, we're going to go play, doing the kind of stuff that we like to do. And then I say, hey, wait, Chris, you come to my house. We'll do something different. Abigail, you come to my house, but make sure you bring Noni the cat. Child, we miss you, haven't seen you in a little while. Come to my house too. And they all get to the house and they knock on the front door. And my wife says, Chris, it's good to see you. She gives him a big hug and walks into one room. And she sees Abigail and she says, I've been looking at pictures of your cat now for the last year. I've been dying to meet you. Here you get this room. Here's some tuna for your cat. Mike cooked some shrimp and scallop for your cat this morning. Give it to Nona because he wants her happy. And then Chow came over and we gave her a second room. It's the same thing. You get to the house and you get the more specific directions. That's what supernetting is going to be. We're going to be hiding routes. Now, why do we do this? And this determines the ability of your networks to work or not work. Get this wrong, and everything is a disaster. We'll do the math, and then we'll do an exercise. I don't want to provide a lot of knowledge to anybody that doesn't need it. So here's what happens when a WAN link goes down on a router. Your phone company's link goes down. The routers recalculate the routes. You got a subnet, which is a layer 3 switch. It's got one server in it. Somebody reboots the server. The whole subnet flaps. Tells everybody to recalculate their routes. I got a WAN link between my New York and my London office. In my London office, there's 10,000 subnets. In my New York office, there's 10,000 subnets. The link flaps up, down, up, down, up, down, up, down, and I've still got a backup link. Every time the thing goes down, 10,000 withdrawn routes come out, 10,000 routes come in. 10,000 routes come in, 10,000 routes come in, to the point where we created something in BGP called Bgp Dampening, which says if this happens a lot, just don't respond to it for a period of time. The routers are calculating. But if, for example, I've got 1,000 subnets in the 10.0.0/8 address space, and I only send the 10.0.0.0.h address space, and the link fails, guess what happens? I lose a subnet. Is it losing one subnet any kind of heavy-duty recalculation on my routers, depending upon which country you're in? Not at all. It doesn't matter at all. Everything's going to be purpose. So these are the reasons why we're doing these things. I want to make it very clear that you all know why. That's why we're doing this kind of subnetting and supernetting. We're subnetting down for the following reasons. We want to be useful with IP addresses. We're supernetting to optimize routing. Now, what we're going to do next is I'm going to teach you how to supernet. And then I'm going to show you what happens when people that don't understand subnetting, that only you know how to use a subnetting calculator, do it. And I'm going to show you where it breaks. But before we do this, I got to teach you how to supernet. So that's the next phase of what we're doing. So if subnetting is take a pizza and chop it into 16 slices, Supernetting is gluing those slices back together on the route side that we send to everybody else. What does this mean? So in this particular case, we're going to do some supernetting. 192.168.0.0. That's a /24, right? How many network and total subnetting bits do we have? 24. How many subnetting bits do we have over here? 192.168.1.0. 24. A /24 gives us how many hosts per subnet? 2 to the 8th minus 2. 254, right? Okay. 192.168.0.0. 192.168.1.0. A /24 and a /24. How many hosts is that? 1,024, right? Or 1,020. I have to do the math in my head. But it's going to be 2 to the 9th, or 2 to the 9th. Now, mathematically, exactly, Eugene, 510. Thank you for the math, Eugene. Which is why it's not good to present and do math in your head at the same time. Now, could I not take this plus this and subnet in the opposite direction for the routers? Keep these same subnets, but put this as address as a summary address on the router. If I want to add a /24 and a /24 together to get 500 hosts, what kind of subnet gives me 500 hosts? Is it a /23? So could I combine, mathematically speaking, 192.168.0.0 with 192.168.0.0/23? Is this the same as, I've got a pizza, it has 8 slices. Instead of giving you 1 slice, I give you 2. You now have a quarter of the pizza. Same thing. That's all it is the same thing. Now, could I then, and I'm going to show you where this won't work. Could I then take this subnet and this subnet and aggregate them together into this, at least on the router side? I can. Here's a question for you. Is there anything to preclude me from taking this, assuming my IP addressing plan is right, and this, putting them together and creating this? It's the same thing. Now, if we have the routing, here's what's going to happen. Let's say we had another router on this end. This router in its routing table sees 192.168.0.0 go here. So the router is going to send its traffic. Here's what's going to happen. The router, and this would be the AWS router, it's going to send its traffic to here. Now, once the traffic hits this router knows all about these subnets and can send it to the right traffic. Does everybody see this? Does everybody see what we did here? This is what keeps networks from crashing and not crashing. So does everybody see this? Well, Radek, Chris, are there any questions that I don't know about in the chat box? I want to make sure we address them before we get to the next thing, because now we're going to get into the cool stuff.
I haven't seen any. Let me just do a quick scroll back through. While I'm scrolling, if you want to talk about the things that we have coming up.
Exactly. That's a fantastic idea. So while we wait for Chris to check the questions, tomorrow, BGP workshop. Nothing more fun than BGP. Now, for this one, I'm going to have to get a little geeky. I got a hat with a couple propellers on. I'll be wearing it ahead of time. I'm channeling my inner geek. free BGP workshop tomorrow. I got to tell you, I've interviewed 1,000 AWS certified people, and those are just certified. Unfortunately, we're not hireable, but we've gotten more than 100 people hired this year, and we know exactly how to do it. So tomorrow morning, I'm going to run a How to Get Your First Cloud Architect Job webinar. And in this webinar, I'll tell you exactly what you need to learn to get hired with us or on your own. I'd love to train you, but in either case, I just want you to know what you need to know and how to learn. So there's How to Get Your First Cloud Architect Job webinar in the morning, BGP webinar in the afternoon. And next week, we're going to do this. We're going to have a free AWS bootcamp. And Chris, I probably have a free interview thing coming up at some point soon. If not, could you make that happen within the next month or so?
Yeah, we can make something happen.
I want people to really know how to interview on these jobs. So if you can make that happen in the next month, find some time when I can do it. I know you know my schedule, so and your schedule and the rest of the team's schedule. So if you can figure out a time that we can make that happen, I'd love to do it free for the community.
Sure.
So join us for the free How to Get Your First Cloud Architect Job webinar tomorrow, the free AWS training last week, the free BGP workshop tomorrow, and please rewatch this because I want you guys to get it.
And don't forget, we got a special show on Tuesday night.
Carlos, you want to know what it takes to become a cloud security engineer? I will help you. That's exactly what we talk about on tomorrow's webinar. So what'll happen is I'll talk for about 45 minutes to an hour, and we will dedicate an hour to answering your questions and build you your plan if you desire with us. And if I run out of time, Alonzo will answer more questions because we're going to help you all.
And don't forget about our show next Tuesday night.
Oh, yeah, you're right. Next Tuesday night, kind of like my young student friends, kind of like my little brother, another person that I wish he was my son. Truth be told, Delray Bat, he came to me a year ago, got him his first tech job, and now he's got his first cloud security architect job. He will show you how he did it. I'll talk about what we've done. He will tell you exactly how much soft skills, executive presence, communication skills, and emotional intelligence took to get the job. He will tell you what recruiters told him, what they were looking for, versus what the hiring managers told him they were looking for. He's a wealth of knowledge at his young, fine age. He visited me in Florida a few weeks ago. He even helped me pick out a TV. And we had lots of great time, and he's coming to Florida soon. So really want you to be there. Almighty, thank you so much.
All right, and Mick has a question that I put on the screen.
And I'm trying to find my StreamYard window to even see what stuff's moving around. Can I go over the last few steps of supernetting a /24 to a /23? Mick B, absolutely. Of course. So let's go back to this. So, and this is only going to work with contiguous subnets. I got one pizza slice and another pizza slice, and I want to show the world it's a bigger slice. So actually, we're going to do another example anyway, so hopefully it becomes clear on this example. And if it's not, we'll make sure it's clear. Let me just figure out how to pop this over here, and let's get rid of this over here. So now, let me go fix these subnets to make sure they work. I didn't make these slides. I gave some guidance on these slides, and I had one of the best people on my team help me make these slides so they'd look good. Because if I made them, box, and I wanted them to look a little better. So I had a professional that really knows how to do this, make it look extra good. And what you'll see is early in your architect career, by the way, you'll be making your Visio diagrams, your Draw.io, your Lucidchart diagrams. The better you get in your career, you're going to be making a lot more architectures, and they're going to be billion-dollar plus architectures. You're going to be writing thought leadership documents, et cetera, et cetera. And you won't have time to draw pretty pictures because you're going to be traveling or people will be demanding on you constantly. And you're going to write pictures on a napkin, take a picture of it, and you're going to send it to a graphics professional. And they're going to make your architectural diagrams in Adobe InDesign, and wow, they're going to look good. But, you know, in this case, we're doing the best we can with PowerPoint, and that's why I had a graphics professional make these look good. Who's also a cloud architect. So in this particular case, let's do it again. It was Mick B, right? let's take.
It was.
And I don't know what happened. Okay, never mind. So we're going to take the MICB, we're going to take the 10.0.0/24 and the 10.0.0/124. So let's think about this. Let's put them together. This gives us how many hosts, MICB? 2 to the 8th minus 2, which is 254. This gives us 2 to the 8th minus 2, which is 254. 254 plus 256. Well, 254 plus 254 because they're actually going to be two subnets. If we want to combine them together, this is 24 bits of subnet mask. Remember, when we go back to this, here's what we're dealing with. Network bits, subnet bits, and host bits. So let's go back to this /24. I've got this plus this, which gives me this, right? Yes. Did I go right? Yeah. So 8 plus 16 plus 8 is 32. So let's copy this. I think it'll make it a little easier. We're going to go right back to the same situation, but I want to take this slide again so we can deal with it. Now let's get rid of these. So let's take this same subnet, get rid of the letters in front of it because we're dealing with classless interdomain routing now. So if you think that this is 8 plus 8, so we've got 24 total network bits. If I want to combine these two, what I can truly do is I can combine them together by putting 15 subnet bits instead of 16. So 16, I've got two separate networks. At 15, what's going to happen is this 8 becomes a 7 host bits, and I get twice as big of a network. I'm sorry. At 15, we're going to have 9 host bits. At 16, I've got two subnets of 8 and 8. But at 15, I can combine them together as this and this. So all we're doing, move to the left, move to the right, move to the left, move to the right. That's all it is. Now let's go back to this situation that we were in before. If I want to take the 10.0.0.0/24 and I want to combine that with the 10.0.0/1, what do I need to do? I need to get an extra host bit and one less network bit, which brings me to the 8 plus 15 and 9 that we were at before. So this 10.0.0 and this 10.1.0.0 can really be summarized for these two addresses in terms of 10.0.0.0/23. And these addresses, I'm just showing you the ways we can aggregate it. And we could also take these next two addresses, the .2 and .3, make it that. Okay, now let's bar another host bit. I got two subnets of 8 plus 15 plus 9. Let's go the other way. 8 plus 14. 8 plus 14 equals 22, which gives us 10 host bits. So what's that going to look like now? Now we're going to we can further summarize this down to this. This is the equivalent. Now you're going to have to know how to up and go down in the leak specific subnets, etc. for the BGP phone we're going to have tomorrow. But this route will cover these two routes. These two routes will actually cover this route. Want to have some more fun with it? Make this another one. 0. Or 5, play with this a little bit, 6, and 7. Get rid of this last one over here. Now let's have some more fun. I'm just doing it step by step. I would summarize it all in a single step, but it doesn't matter. We can do it this way. 10 into this. 10.0.4.0/23. Yes, it can. No, could we take 6 and 7? 6 and 7. Could we summarize 6 and 7 as 10.0.6.0/23? Yes, I could. We can, right? Okay, now, could we then take these two and summarize them to 10.0.4.0/22? We sure can. Hey, everybody, you see where this is going? And I could have done them in one fell swoop. Can I take this? And can I take this and combine them into a single root? Well, if I do, now what do I have? I currently have 8 networking bits, for example, because it was a /A that we subnetted down, class A that we subnetted down. And I've got 10 subnetting bits. And 10 subnetting bits plus gives me how many host bits? 8 plus, how many did I mention before? 8 plus, so we're /22. So but it gives us 8 plus 14. So now what if I wanted to create a /21 that would cover this and this? What about this host root? Or this rate, it's not a host root. 10.0.0.0/21. Does that cover these two? Yes. And do these two cover these four? Yes, they do. Here's where it works. That's all we're doing. I wanted to do a second time for you guys anyway. So what we're doing here is for subnetting, we're chopping into little pieces for efficient uses of our IP address. Because we don't need to know this. So let's say I've got Eva Doika over there. She's in Scandinavia, and she needs to go any place in the world. If I said, Eva Doika, meet me at London Heathrow. And she got to London Heathrow, and she said, I want to go to Dubai. And I say, no problem. Jump on that Emirates airline flight. You're going to love it. And she says, I want to go to Greece. And I'm going to say, jump on Olympic Airlines, and you'll get there, and it's going to be fun. And she says, Mike, I want to go to Australia. And I say, jump on Qantas. It'll be fun. I don't know if they're still there. I haven't been to Australia in a while. I used to go there all the time. And she says, I want to go to Panama because it's a beautiful place. Pretty sure British Airways has a flight there. I'd say get on that airplane. She does not need to know the directions on how to go everywhere. All she needs to know is how to go to London Heathrow and which airplane to take. That's what we're talking about. Now, here's where it's going to get bad. Right now, I use contiguous addresses like you're supposed to because I know networking. Imagine if we tried to summarize routes where somebody else had half of those routes with them. Chris, go to the airport. The Orlando airport has the 10.0.0/8. The Fort Lauderdale airport also has 10.0/8. And the Tampa St. Petersburg airport has a 10.0.0/8. Where do you go, Chris? You don't know. And that's the king. You can't summarize routes that you don't own because it's going to cause blackholing of your traffic, or your traffic will get lost. So 90% of the problems we see in networking are related to somebody that put the wrong addresses on the wrong places. 90% of the time. So let's look at it this way. Let's look at something we can't do now. I see this all the time. You got a DevOps engineer, and a DevOps engineer is a great person to have on your team. And someone said, you need 4 subnets. Go subnet it out. The DevOps engineer is great at their job, automation, Terraform, dealing with automation of software release cycles. And they say, I got it. I'm going to put all these /24s there. Now, in this case, I got the data center and I got the cloud. Do not make this mistake. This mistake is not good for you. Let me change the color to this cloud. Bear with me. That didn't work. Not sure what's going on here.
You may not be able to do it with that one.
Here we got a cloud. Now, let's pretend for right now we wanted to use this subnet in the data center. 10.0.0.0/22. Here's a problem. This would work, except 10.0.0/22 includes 10.0.1.0, 10.0.0.0, 10.0.2.0, and 10.0.3.0. Can I put 10.0.0.0/22 in my data center? I can't. And here's the reason I can't. Because one of those subnets is sitting in my cloud. So I can't do it. Now, with this bad addressing scheme, I could do 10.0.0/24. And I see this all the time. And I could potentially put in this, I could have the route 10.0.2.0/23. And what route do I have to have over here? This 10.0.1/0. That's a problem. Here's why. What happens when my data center has 100 subnets and 200 and 300 subnets? And 50% of those subnets are on the cloud. And 50% of those subnets are in the data center. I now got to send every route I have. So what you want to do is you want to isolate your data, your addressing to the following. Put what you need in one thing and use completely different CIDR ranges in different areas. By doing this, you can isolate it. This is an example of everything not to do. I'm going to tell you, 90% of all internet outages I've dealt with in my career is related to this. Who should IP addressing scheme? The most senior person on your team. How you plan your addresses will determine how many routes. If London Heathrow does 15,000 flights a day, do I need to know all of them? No. I need to know. I get on my computer. I book a flight. I leave Palm Beach, I leave Miami. I fly to London Heathrow. From London Heathrow, I go visit my family in Athens, Greece. Life is good. Easy, right? Because I know where to go. I'm really late. I'm running short on time. I get a call that says, you must be in Philadelphia in 4 hours because of an emergency. I'm 30 minutes from Miami. I just go straight to the Miami International Airport. I look at a flight bird, and I see Delta's doing it. JetBlue's doing it. American Airlines is doing it. I find the quickest flight. All I need to do is get to the airport. So kind of keep that in the back of your mind. Now let's look at the good way to do it. And before we do it, let's look at it this way. Now I'm concerned. I want to send one route to the cloud, just one. The cloud's got 50 subnets, and I only want it to send me one. Look at this. Same situation. Now I've got these 4 contiguous subnets in my data center. All I need to send to the cloud is this one route. All the cloud provider needs to send me is this one route. That's it, just one. Now, once my traffic gets to the cloud routers have all the intelligence that I need. Once they cloud sends the information to the data center on the 10.0.0/22 and hits my routers in the data center, guess what? They know exactly where to send my traffic. So I'm just trying to hide it. I'm trying to hide the routes. All it does is it determines how to get your traffic from point A to point B by giving the most intelligent people information to the routers that need it. Now, I want you to think about this. Are all routers created equal? No. I can buy one router from Cisco, Juniper, I don't care. And it's a mini router for $3,000. It's got one Ethernet port, a gigabit Ethernet port, and who knows, it can deal with 300 megabit per second of throughput and 1,000 routes on the routing table. I can call Cisco and Juniper and say, I need a core router that's going to have 2 power supplies and 2 brains called control modules, a bunch of line cards. Now, this router can take in 5 million routes. It's also $500,000. So think about it. Who needs to know what? Your big core routers need to know everything, but not everybody needs to know. Segmentation, segmentation, segmentation. And by doing it, that's how we do it. Give you some secrets and guidelines, and if you want, I'll show you how we architect a network to do these things. If you desire that, we don't have to. If you've got a Cisco router and it needs a loopback address, what's a loopback address? It's an address that you put on the router that never goes down. It's a host. You can use something called a /32. What is that? 1.1.1.1. Some mask. 255.255.255.255. That's it. It's a host. For WAN links, you typically use a /23, a /30. Why? 255.255.255.252. Hey, Chris, I need a wire between you and me. Chris is on one end, I'm on the other. Chris needs an address. I need an address. We're attached to a wire to each other. Can anybody else fit on that wire? No. It's wire. Do I want anybody else on that router? God, no. I don't want them on there hacking into me. So they don't have an address. /30 is for WAN links. For a LAN, just because the smallest subnet you can use is a /28 doesn't mean you should ever use it. Here's why. You got Cindy, Noni, Sunny. They're all having a good time. And then Joey comes online. And then Alberto comes online. And the cats develop some boyfriends. Some of the cats get married and have children. Are they going to fit in the subnet that's only going to give them 4? Of course not. They grow. And here's the thing. If you think you need 4 servers, you'll have 200, I promise you. In my youth, I didn't realize it. I need 30 addresses. Sure, no problem. You got 32 addresses. A week later, hey, Mike, we need to readdress everything in the subnet. Okay, fine. Here, you got 64. I doubled it up for you. 3 weeks later, Mike, it's not big enough. Here's your /24. I learned that lesson a long time. How big is a /24 in the LAN link? I didn't waste your time. /30 in a WAN link. But you must know how to take your /16 and break it down. So what is classless interdomain routing? We used to have a subnet, a class A, class B, class C. About 30 years ago, we said, no, they don't make sense. They don't make sense. And what we're going to do there is we're going to do the following. So let me try and think about how I can answer James Yang's question in the chat box right now. Chris, if you want to bring in that question, let's figure out how we can answer that.
Then we got some others also.
Okay, so let's answer some questions, and if you guys want, I'll show you how to put it together. You don't understand how one IP address is in the range of another IP address. Okay, so 10.0.0.0/24, 10.0.1.0/24, 10.0.2//24, and 10.0.3/0/24 can be together supernetted to 10.0.0/24, or /22, and it's going to work perfectly. But what happens if I want to do that, but that other subnet is sitting somewhere else? It's kind of like this. Let's say I wanted to sell Hondas, and I wanted to be the biggest distributor of Hondas in all of Florida. And by doing it, I said Honda cars. If I told the world, everybody's Hondas come to me, but at the same time, there was another Honda dealership, and I told all of his customers to come to me because I was advertising the big subnet, there'd be a problem. He wouldn't get any visitors, which would be good if I'm trying to steal his business. but not good if both of us needed to do business. By comparison, if he went out there with his specific subnet and decided to aggregate it, he might be telling the rest of the world, I've got all the cars in the world, and my business would be done because all the traffic will go to him. So think of it this way. If we got two people saying, I've got this, where does your traffic go? You don't know. So when you're dealing with subnetting, you're taking things down and you're breaking them down. When you're dealing with supernetting, in order to advertise a route, you must own the route. You can't advertise somebody else's route. And when you supernet a route that's in somebody else's data center, one or more of you does not get the traffic when you need it. And that's the big problem. I hope that made sense to you. Chris, let's go to the next one. Why would you use a Class B address for the cloud? I always start with the Class B out or a Class A and subnet it down, and here's the reason. I don't know how big it's going to get. Private IP addresses are free. They're all free. The 10.0.0.0/8, I can create 254 Class Cs out of it. I'm probably have to do the math in my head, but I think it's 254, it might be 255. But I can create that many Class Bs out of it. So imagine this. 10.0.0.0/8 in my data center. That gives me 65,000 addresses. 10.1.0.0/8 in AWS. 10.2.0.0/8 in Azure. 10.3.0/8 in Google. Now, well, how many routes do I need in my routing table? 4 of them. One for Google, one for AWS, one for Azure. Why do I go big? They're free, Al. So if I use something that's bigger than I think it needs to be, I'm not going to run out. Here's the thing. I decide to subnet a /24 at Class C for my WAN, and I run out, then I'm in trouble. So when it doesn't cost you anything, give yourself more space. Hope I answered your question there. It's a great question. What are network bits and host bits? We got an IP addressing thing. You can either on the network side or the host side. So network bits are as following. 255.255.255. They're your 24 networking bits. Your host bits are the .0. Class B address. 255.255.0.0. Got 16 networking bits and 16 host bits. The host bits are how many hosts you can have. Network bits are how big your networks are. Sig Wolf. How would you deal with an environment of 350,000 users, deal with it every day, and 10,000 servers as a physical and virtual? Do you still do /24s and /23s per subnet? Absolutely. You have no choice, and here's the reason why. Go to a restaurant tonight, Sig Wolf. I think you're in Germany. And when you go to this restaurant, imagine 10,000 people are in the restaurant, and they're all talking, yo, let's talk about where we're going. How about the football game, Joey? Hey, I met this person. She was really pretty. Hey, I met this guy. He was really cool. Hey, I'm going to sell this stuff to you. I got the best thing. I got to sell it to you. And now, hey, sports. Ah! You're going to hear this in the restaurant. That's what it's going to be like. 10,000 people in a restaurant. What's it going to sound like? Man, it's chaos. Now you want to have a romantic conversation with your wife. Can you do it? No. Because there's too much noise. Sig, you're in New Jersey? I don't know why I thought that. For some reason, I thought you were in Germany. Apologies for that. So there's that. So that's why we can never get more than 500 hosts in a subnet. Now, if you did, Sig, here's what would happen. Broadcast, 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 broadcast. What's going to happen? The broadcast will hit your router CPU, and the router CPU will go to 100%, and your network's going to break. Next, your servers are going to be broadcast, whether it be ARP broadcasts or Bonjour broadcasts or whatever it is. They have to process each broadcast too. It hits the CPU. So your CPUs, if you put 10,000 servers, would be at 100% doing nothing other than responding to each other's broadcasts. So we can never put more than 500 systems in a single subnet. So here's what we'd have. Subnet 1/24, Subnet 2/24, Subnet 3/24, Subnet 4/24, etc., until we're done. Because otherwise it'd be like that restaurant. Everybody's all screaming. It's kind of like a sporting event. Not exactly in the middle of the sporting event, like a soccer game or a football game in Greece. Go there. All of a sudden somebody does something that's cool. It's all loud. I put earplugs in for that reason. Still do /24/23s every single time. Beta UI, would IPv6 render subnetting knowledge obsolete? Not at all. Here's the reason why. Most addresses are still IPv4, 90% of them. And you do subnetting with IPv6? Of course you do. Here's the reason why. You can't put more than 500 hosts in a subnet no matter what you do. So, do you want to burn billions of addresses? No, you will always need to subnet for the same reasons we're subnetting here. I said, Wolf, I'm curious where you're at in New Jersey. I lived in Princeton for a long period of time. How do we deal with DHCP access list routers and how about on DHCP servers to efficiently process the request? Interesting. Okay, so a router constrains broadcast. So I'm in a subnet, and I say I boot up and I want to be a DHCP address, and I do. Hey, who can give me an IP address? It's called a DHCP Discover packet. And then the servers respond with an offer. And then I say, hey, I'm taking this address from this server, not this one. And then I get given the lease. West Windsor, well, we live in the same place. So there's that. Kind of keep that in the back of your mind. Now, can a broadcast get off of your subnet? No. So in the old days when I started, and the dinosaurs roamed the earth, and routers basically could pass 1.4 megabits per second of traffic with the CPUs at 100%. I'm not joking. In those days, we put the DHCP server in the same subnet. And then what Cisco went, we can't put a DHCP server in every subnet. And they came up with the concept of the helper address, which did the following. I'd send out my DHCP Discover packet. It hit the router would say it's a DHCP Discover packet, and it would forward it to the DHCP servers in another subnet, and then it would send it back. To me, it was a rule to break the rule. Kind of like a route reflector breaks the rules of BGP being non-transitive, and Transit Gateway and Cloud Hub will enable you on AWS to break the rules of VPC pairing being non-transitive. It's the same kind of concept. It's just a rule to get off of the subnet with a broadcast. Good question there. Now, when you're doing this, you got to set up your DHCP servers to basically do /24, /24, /24, and /23. Where are you going to do your supernetting? On your network devices, your routers. So your network architects will design the plan, and your network engineers will put it and configure it on the routers. So on the router that sends your routes to AWS, you have to do this. On your direct connection router, your VPN router, this is where you're going to do it. Not on a DHCP server. This is networking, not server admin stuff. That's a good question. Who else has questions? Any others that I missed, Chris?
Nothing right now.
So what it all comes down to is tuning and traffic optimization. That's all we're trying to do. And let's go back to that contiguous subnets again that James asked. So Cindy the cat's at my house. If Chris told the world, send your internet traffic to me for Cindy the cat because I got Cindy the cat and she's doing cute stuff. And I'm telling the world, I've got Cindy the cat. Where's the traffic going to go? Half to Chris's house, half to my house. But I'm the one with Cindy the cat. So that's why we can't summarize routes that we don't own. If we do. So it'd be like this. Let's say you've got two restaurants. They make souvlaki and gyros and choriatiki salatas or Greek salads and all this great Greek food. Really good stuff. You can get some baklava there, some kadaifu there. You can get some mythos or some alphabia there. It's a really great place, okay? Two great restaurants. You got both restaurants. And they both say, Mike's here eating dinner. Can I be in both places at the same time? No. But if they told the world, Mike's here, and then somebody wanted to find me, where would they go? So that's the problem. Now, if this one said, Mike comes here for breakfast, and in breakfast, Mike eats 4 eggs, turkey, bacon, and a bowl of blueberries, and his eggs are cooked in olive oil, and with that, he takes 12 fish oil tablets, a ginger or turmeric for his arthritis. And the other one said, I got Mike, he comes for dinner. He eats his choriatiki salata, which is a Greek salad. He eats some kota, which is chicken, and he eats some fasalakia, which is green beans. You want to find Mike for dinner? He's going to be here. We're good to go. We're good to go. So that's why we can't tell things otherwise. I can't say I own something that I don't and tell the world about it, etc., etc., etc. Can I list some avenues where you can practice network subnetting? Yes. On paper. You're not going to be doing any of this kind of networking stuff heavily. This is on the cloud. And so the key is subnet is a design. I don't care how you can configure an IP address. That's almost irrelevant as far as I'm concerned, unless you want to be a cloud admin. I care that you know how to design it. I'm an architect. I don't touch the tech ever. I'm an architect. I design it, present it, and convince the customer they need it. I design something to solve a customer problem. Where can you practice subnetting? PowerPoint, Microsoft Excel, Word. You can take my free CCNA training. So I want you to think about this. If your practice was just typing in codes on the computer, did you learn anything? Absolutely not. You learned how to put an IP address on someone. And actually, while we're at it, that's what's wrong with Learn by Doing labs. When we do BGP tomorrow, I'm going to teach you how to architect it. When you take the Cisco Certified Internet Expert exam, they give you the instruction manual, and they still have an 80+ failure rate. Here's the reason why. They ask you, design an area in OSPF that has no Type 5 LSAs that still allows external routes to be redistributed. Now, if you don't know that's a not so stubby area where an external route becomes a Type 7 LSA and gets converted by the ASBR, the router, to a Type 5 LSA when it gets injected to Area 0, you have no idea how to do it. Now, sure, knowing the command stub no summary is irrelevant when it comes to designing it. You need to know the kind of area you need. If I tell you and tomorrow we're going to do it, that you've got 2 equal cost paths to AWS and 2 direct connections, and you don't want to voter packets, I don't care if you can type router BGP 65312, network 10.0.0, mask 255.0.0.0, neighbor 192.168.1.2, remote AS 65313. I don't care if you can do that if you're an architect. It's irrelevant skills. What I do care is that you know that you can link a more specific subnet on this link versus this link, that you can prepend ASs to make this route look ugly and this one not look ugly, that you can change the weight of this route, so this one's preferred versus this one, that you can change the local preference of this route versus this route. If you want to be an architect, Dave, and I don't know your career, but if you come tomorrow, I'll tell you what to do. It's all design. Where do we practice? We practice on paper. What do we deal with our customers? I meet a customer, I ask them questions, I build a design. I present the design back to them, I negotiate the deal, and as soon as they're ready for it, bye, customer. Here's my team of cloud engineers to go build it. So where do you practice subnetting? This is a paper experience. You can't practice architectural design by doing. That's implementation. So what we're talking about is architecture. Now imagine an architect that's going to design a building. Do you think it's good practice for him to use a screwdriver or use a nail? to design buildings? Of course it's not. It's a totally different skill. So practice this on paper. Subnetting is planning. This is mission planning. It's done on paper. So where should you do this? You should go to our completely free CCNA training. Chris, pop that link. And you should buy the Cisco Press books for the CCNA course from Wendell Odom. Why? He works for Cisco. He did in the beginning, at least for a while. His CCI number is 1024. That's where you're going to do it. He's going to have you practice on writing the same way I am, because this is a planning thing, not an implementing thing. Different job, totally different role. Great question, though, David. Excellent question. What type of IGP? You're going to be using, well, I've worked with two internet gateway protocols, OSPF and intermediate systems to intermediate systems. But Joe, about 20 years ago, even when I worked for Cisco, I started ripping out EIGRP. And for those of you that don't know, EIGRP was a distance vector protocol that Cisco liked to call a hybrid protocol. And what happened was as follows. It was Cisco proprietary. Who runs an all Cisco network? Nobody. So Cisco was like Cisco, just like AWS said, here, use our really good enhanced interior gateway routing protocol. And it was a good protocol. And it had some performance tunes. Now, once you had this, and a Juniper network router came in, you couldn't work with it. When you dealt with extremes, you couldn't work with it. It all became, it's too proprietary. So that forced people on the networks where they can only use Cisco. About 20 years ago, I wrote my first EIGRP to OSPF migration document. So companies generally use OSPF. Now, the other interior gateway protocol that's used is intermediate system to intermediate systems, the old CLNS routing protocol. And the reason this is used is it works very good in a big flat network with L1 routes, where L1 is intra-area, L2 routes are intra-area. So you can create a very big, large, flat L1 intermediate systems area. And the reason we're using OSPF single area for a service provider versus a customer who uses multiple areas, and the reason we're using intermediate systems to intermediate systems is the information that can be contained in those link state advertisements, which then enables us to run some RSVP signaling, turn on some label switching, and build our backbone on MPLS with primary paths and backup explicit paths, etc. So what kind of routing protocols? It's OSPF and intermediate systems as a rule. There are still some EIGRP hiding out there, but anybody who's serious about their network is not using it. I mean, why would you ever? It's kind of like using DynamoDB. Here, I'm going to use DynamoDB, and it's a great database. It truly is. Now, I'm stuck on AWS. When AWS has their next outage, I'm done. When they raise my prices and I want to go to another cloud, I'm done. But I can use MongoDB and stick it on AWS, Azure, my data center, Google, and nobody cares. So don't use proprietary anything. So it's OSPF, intermediate systems. And it's a great question. Love that question. Any others for me? Okay, so let's remind you, tomorrow we're going to have some BGP fun. That's going to be really good. And we're also going to have our How to Get Your First Cloud Architect job webinar. And that's really important that you guys know what the jobs are. I got to tell you, it's really hard to find a cloud architect. It's really hard to find a good quality cloud engineer. And the problem is, in most cases, people are prepared on everybody else's job other than their own. It's truly sad. People work so hard, and I love BGP2, Evadoika. I love it. It's my favorite protocol. I have 10,000 hours experience on it. You have to know your job. And on tomorrow's morning, we will tell you exactly your job. You'll see why our students get hired. My psychologist just told me she was hired. Delright's like 25, he just got hired. Yesterday, somebody in Australia told me that I got 3 notifications just yesterday. And the reason is my students know their job, and they know it really well. They don't know anybody else's job. I'm going to tell you that right now, because I make sure that they focus on their job. If you went to a doctor and they said, I'm a great chef, would you have confidence in the doctor? I wouldn't. I'd say it's great, but I need you to fix my heart, my cardiovascular disease. How is you cooking me a steak going to help me? It's not relevant. If your airplane pilot said, I went to law school, is that going to help him fly the plane or her fly the plane? Of course not. If my veterinarian that I took from my beautiful cat named Cindy, who's like the second love of my life after my wife, told me, I'm an expert at jumping out of airplanes, I say, how's that going to help you take care of my cat? So, give me a hashtag that says networking and cloud computing, please. And a hashtag that says cloud hired, because that's what we do. We get people cloud hired. And you're more than welcome. Many thanks. Interesting building in the background. Thank you so much. Tracy May, thank you, Mike, and the Blue Wrench team. We're definitely have to go back and watch tonight. Please do so. Look, this isn't easy. If it was easy, we'd be paid minimum wage. It's complicated. There's a lot to learn, and that's what we're well taken care of. Y'all, thank you so much. I love that photo. I got to see it sometime. Dustin, that plate looks really good. Russ, Networking Cloud Computing, thank you so much. Over and Weaver, Cloud hired. Russ DJ, Cloud hired. Mr. Gee, Cloud hired. KMA, Networking and Cloud Computing, yes, but not sure how to say that. Cloud hired. Sigwolf, Gay Class, thank you so much. Thank you, Sigwolf. Eva Doike, Cloud hired. Happy to see you, Eva Doike. You have no idea. Chindu, Cloud hired. Leonardo, Networking and Cloud Computing. Russ DJ, thank you so much. You're more than welcome. Nikhil A, Networking and Cloud Computing, good to see you. Cloud hired. Mick B, thank you for the wonderful session. Looking to BGP, TCP port 179. Yes, yes, yes. Eva Doike, Networking. Yes, Tracy Me, Networking and Cloud Computing. Yawn, Networking and Cloud Computing, my favorite things in the world. KMA, Cloud hired. That's my favorite message you're saying. Eva Doike, Cloud Computing, perfectly. Brian McCool, Networking and Cloud Computing, Cloud hired. Yes. Jindu, Networking and Cloud Computing, and Nikhil, Cloud hired. Travel Benji, Cloud hired. Alonzo Coleman, my brother, Cloud hired. Beta UI, Networking and Cloud Computing, yes. Thank you, sir. Team Replay, yes, I think that's great, Chindu. Joseph Partwork, Networking, Cloud Computing, and Cloud hired. Joseph Parker, you're going to get there soon. Alonzo Cold, Cloud Computing, and Charles Finney, Networking and Cloud Computing. I'm loving it. Mick Bean, Networking and Cloud Computing. Robert Welch, Networking and Cloud Computing and Cloud hired. Yes, Tracy May, Cloud hired. Eddie Patrick, my good friend, and he's so amazing. He's with us, and he's in Bamenda, Cameroon. We love him. Leo Paredes, thank you, and Cloud hired. Yeah, you are the best, Mike. Thank you so much, Ja. I appreciate that more than you know. Leonardo, thank you. Go Cloud Careers team. Always high level content. Thank you so much. Networking and Cloud Computing. You guys are music to my ears and making me happy, happy, happy. Thank you. Alonzo Colward, Networking. Yes, 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 yes. Beta UI, Cloud hired. Carl, Cloud hired. Carl, I've been seeing some pretty interesting stuff out of you very recently, and I'm all kinds of excited about it. Alonzo Colward, AWS Networking. Curtis Robinson, Cloud hired. Ivadaiku, thank you, Mike, Chris, my lovely teammates are awesome. I am so happy you're here. You have no idea. Cloud hired. Alonzo Coleman's in Katy, Texas. Yes, he is. Marweezum, awesome as usual, and the Go Cloud family. Thank you so much. Carlos Peace, thank you, Mike. You are so welcome. I'm so happy to have you. Juice Jones creates. I love that. Cloud Computing, thank you so much. Looking forward to tomorrow. Sean Z.O., Cloud Architect, I'm loving this. Networking and Cloud Computing, thank you so much. Networking and Cloud Computing, I'm loving it. Mr. Pitts, Cloud Computing and Cloud hired. That's the reason of my life, my mission. Bob, thank you for sharing your knowledge. I'm so happy to help. And Mr. Gee, Networking and Cloud Computing, fantastic. Kemi Thompson, you enjoyed this. I am so happy. Solomon, Cloud hired, thanks. Mario Millen, Cloud hired, and thanks. Alonzo Coleman, thank you. And if you're at it, please hit the like button and subscribe. Please subscribe and tell a friend. We work so hard, and we spend a fortune. Thank you, everyone. Thank you for providing such great Mike. Thank you, Chow. Next week, another AWS, completely free workshop. Cloud hired, Juice Jones. Patrick Laguna, thank you, changed your life. Patrick was one of my students. He's now working for Cisco Systems. We love Patrick. He's amazing. Thanks, Patrick. Can't wait to see more from you. Toby Leo, Cloud hired, over there in Liberia. Eva Dorkia, love it, love it, love it. Thrilled you're here. Richard Craddock and team, excellent. Actually, tell me where you're at. I know some folks are in Nigeria, Cameroon, Denmark. Chindu, we try so hard. Thank you so much. Even more, thank you. Looking forward to tomorrow. Interviewing is your weakness. We'll tell you what you need to know. Thank you with love from Nigeria. We love that you're here from Nigeria. We love that. Marjan, thank you for the Blue Ranch crew team. Yeah, I'm grateful for them as well. Nick Me, thank you so much. To Chris, Alonzo, Leo, Chow, Eddie, and the Blue Ranches, of which there are many here today. Raj, Gusha, thank you so much. Paul, Cloud Hired, and thanks. Omar Weaver, Juice Jones, created in DC, Benematic, Cloud Hired, I'm loving it. And Chow is in Dallas. 100 degrees Fahrenheit. Well, I live in Florida, and I got to tell you this. Each day I spend about an hour in a 160-degree room, so 130-degree yoga, because that's what it takes to keep my foot good, and 160 degrees, so I'm with you. Joining from the New York Metro, that's fantastic. I worked there for years. Raj over there in India, fantastic. Bob, Cloud Hired. Of course, Mike, you must defeat BGP. We will teach you how to slay the dragon. You're going to be good after tomorrow. Algeria, wow, love that. Go Cloud Careers in DC. Margin is in Amsterdam. I'm loving that. San Francisco Bay. Spent a lot of time over there, especially cold in the summertime. It feels like that. Thank you, Mike, for this wonderful workshop. Thank you for coming. We love you all. Richard Craddock in Pennsylvania. Grew up in Philadelphia and then Bucks County. Probably from the same place. Kansas City, Missouri. We're going to tell you, the first time I was told they had a flight to Kansas City, I was looking for flights to Kansas. And they kept popping up in Missouri. So I went there. I loved it. Spent a lot of time in Kansas City. So I want you all to have a wonderful, wonderful name. Chris from my team will pop in and et cetera, et cetera, et cetera. So join us tomorrow for the How to Get Your First Cloud Architect Job webinar. We'll teach you everything you need to know, what you need to learn, what the hiring manager cares about, how to leverage your life experience so you know exactly what you need to do to get hired. We'll tell you what needs to be on your resume and what certifications will be helpful to what part of your process, et cetera, et cetera. After that, we'll do our free BGP workshop. And then next week, we're going to do our completely free AWS Certified Solution Architect Associate Bootcamp. Please sign up. The link is in the description below. And I'm going to get on the calendar a free interview training session because I want you all getting cloud hired. Anything we can do to help you. And if you want to be trained and get a cloud architect job as fast as possible or a cloud engineering job, we have our Cloud Architect Career Development Program for what? Cloud architects. And our Cloud Engineer Career Development Program for cloud engineers. So see you all later. Have a wonderful night. Cloud hired, everybody.